going on, everyone? Welcome back. Welcome back. How's everyone doing? Morning, morning, morning. Good afternoon, good evening, wherever you might be. Welcome back to another episode, another stream here at Level Effect, and today we're kicking back up the SOC 100 course once more. Today is Class 24. Class 24 of SOC 100. Windows Triage. We're doing it today. Malware Analysis, we're finally kicking it off. Should be pretty good. See what we've got inside the chat here today. Nice, cool. CI's here. Karina, Zeno, Finac, Blackhammer, Patricia, Joe, Yakpo, Jordan, Alan as well too. Kim's just joining. Nice, nice. Cool, cool. Should be a pretty good stream today. Hope everyone's ready. Hope you got your coffees. Might need an extra dose. We're going to see if we can kick off email security today as well. Let's see how that goes. First order of business is wrapping up Windows Triage. And going from there. So did anyone study more after yesterday's stream? Did everything go well yesterday? yeah, it did, CI. That's, why you asking that? Like with the stream, you mean, or what? KS. Morning. Oh yeah. Sorry, yeah. Everything was good. It's just a bit of a tight weekend over here, outside of work and life and all that stuff. So couldn't do the full 4 hours. But yeah, bearded morning. Thanks for asking though, CI. It's very considerate of you and very empathetic actually, and observational. So thank you, appreciate that. R double morning. Yeah, you know, interestingly enough, so like I've had some time to look at the content survey results that we shipped out. So I was kind of curious, right, to kind of see like stream preferences and stuff. So Saturday and Sunday still the biggest. A little bit of an interest on Friday. So that's a good day to do it. But typically, I think what everyone's looking for in terms of length, it seemed to be the vast, like I mean, overall majority was up to basically 1 to 2 hours, maybe getting a little bit more than that towards a 4 hour mark, but like 0 for anything more than that. So that was interesting, which I think fits okay. I think a 4 hour stream is a lot of education. It's a lot of learning. So I think we'll adopt to that as well too. I mean, even for me too, like teaching for 4 hours straight, like I can do it, but I know by the end of it, like it's so much content. It's just like, okay, well, it's hard to like absorb it all in one go. Code morning. Vaby, thanks for the follow as well too. Had a couple followers happen overnight as well too. So if you're all catching the stream right now, Hot Dog and Moru as well too. Gromit, thanks for the follows, and Jess as well too. Thanks for the sub. I think at some point overnight, looks like. So thank you whenever you're watching this in the recording. But yeah. See, I didn't know how to answer the survey. I mean, just say what's on your mind. Like, what are your preferences? What do you like and why? If you can provide some answers of the other category, you know, but don't feel pressure. And don't think about it too much. Just like, what are your preferences? Cool. Okay, yeah. So today, like I said, we are back. Another SOC100 episode over here. Today's Windows Triage. We are finally going to be taking a look at our first samples of malware today. We're going to be looking at the persistence process and networking activity related to it. So that's kind of our core analyst triad that we refer to, not the CIA triad, but rather our analyst triad that we like to refer to here at Level Effects. So we're going to take a look at that today. We're going to use some tools, Process Explorer, Process Monitor, AutoRuns, TCPView, maybe something else. We'll see inside there, but we're going to do a lot of forensics and analysis from the tier 1 SOC analyst level. So that's the expectation as to where we're going today. We have 3 sample malware that we prepared for you. They're neutered, they're defanged, like they're not the most evil, like, you know, but they're an introductory set of malware to sort of emulate and prepare you for the challenges in this module, which are a lot more challenging. And I think if you can gear yourself to completing the first 3 challenges in this module, I'd say you're pretty set up. Like, if you can get through those challenges on your own and understand it, even if you have to go through it again a couple times, I think you're going to be in pretty good shape. Like, for your ability to perform SOC 1 tier analyst, Windows compromised host triage challenges, types of things, and things that you'd see in the workplace or real life. Let's take a look at a message over there from Vey. Vey, so you've been in the IT field for about 6 years. Starting as a typical tech support professional and progressing to higher level cybersecurity roles. You've earned your CSAP, your Sec Plus certifications along the way. Cool. I've always been fascinated by software development and the process of creating something from scratch. While I feel confident in planning and writing pseudocode, translating those ideas in actual code remains a challenge. I just don't know what approach to go after. Okay, cool. So, all right. So if you can develop the pseudocode for it, I mean, that's more than half the battle. Syntax and learning the language is going to just come from general muscle memory and practice work and just get more and more exposure. So I think that is going to be something that just happens with time and experience. Now, there's a couple different schools of thought on how to actually go about that. Some people like to advocate to do many small challenges of varying degrees of complexity with different types of goals and just kind of build your exposure that way. There's the other school of thought that says just start with something monolithic and big and do a lot of the figuring out as you go. So you're going to get a lot of exposure in one single project. Myself, I'm more on that school of thought because I think in that regard, you know, it'll probably be something that you're passionate about. And if you're passionate and interested in something, it'll be relative to you. You'll be more curious and you'll stick to it. It'll be a little bit more of a grind because you're going to have to figure out a lot more things in that single project and it could deter you a little bit. But overall, I think you're going to get more reward for it. So the first step is to think of something that you find valuable for yourself or that you find interesting enough that someone else has made. Try to write the pseudocode for it and then start researching how you would actually build that. That'd be my recommendation to you, Vey. And if those don't stick, then the third option is to go through some type of like little mini course, some type of nugget on like a target language, and then it'll kind of nudge you along with a lot of general exposure and then maybe try approaches 1 and 2 after that. I don't. So you're saying yes, you know some Python, then obviously PowerShell and Bash. Do you think I should continue mastering Python to create a tool? Ideas to create some type of security. Okay, so I don't ever, unless you are I think unless you are in the business, or it's your responsibility, or it's a value you want to build to the world, of learning a language so well that you can master it and you can deliver it almost like an art. That's why they have like the big famous book, The Art of Programming, for a reason. That is when you get to tiers of like super optimization, super efficiency, super performance, etc. If that's what you want to do, then great. But more often than not, I think you have to kind of dial it back in and realize that delivering on the result is more important than mastering the tool. And you should look at a tool as a vessel to help you deliver that result to the degree that you need it to. And if you focus so much on just mastering the language, you're actually just going to get further and further away from delivering the result. And what that would look like is if you were to build a security tool with some scrappy spaghetti code and it worked and it was valuable and people started to like it and use it, that I think has more importance. And you can always go back in and you can refactor it, and maybe you can build a version 2 later. But at least you get traction. Someone starts to get value for what you're doing. You get value yourself for providing something, and you're also developing skills along the way. I think you should just go right to it and build something, even if it's ugly. That is my recommendation. Does that help, Vay? Honestly, that's a recommendation to anyone here in chat as well, too. Nil, thanks for the follow. Ras Sushi. Thanks for the follow as well, too. Thanks for being here. Cool. Well, that's enough of a bit of a morning rant there for you. I hope that helps, though, Vay, and everyone else as well, too. Just get to work. Start building things. Get your hands dirty and iterate. Needed to hear this? Been in a slump? Yeah, it happens. Analysis paralysis. You know, you keep thinking about, like, what's the best way to do this? And then before you know it, you've just thought a lot about how to do it, and you haven't actually done anything. And then that means there's no reward feedback. There's no loop to complete, right? Part of the realization of fulfillment and satisfaction and happiness to a degree is a span of events. It's not just the immediacy of it. That's where you get like short-term kind of stimulus. You feel good about it, but then you feel empty after and you keep chasing it. But like the true feeling of satisfaction comes from starting something and seeing it through, even if it's not like your intended desired result from the beginning. The act of the full completion and then iterating on it again is going to be a little bit more fulfilling for you, I think. Cool. All right. Let's do this. Let's hop inside the course. We are going to be doing SOC100, Windows Triage module. Let's do this. Oh, I should say, let's, 1 second, I got the wrong thing up. Wrong course. Um... 100-2. Cool. Okay, yes. Windows Triage module. We are back over there, right? Yeah. Cool. All right. So everyone's ready? Ready to do this? Ready for some malware? Finally? Nice. Cool. Okay. Get all my Windows set up and stuff. All right. Where were we at? So we left off yesterday, I think right around here, right? We were just about to get onto AutoRuns and everything. Tom, morning as well. Okay. I think the one thing that I wanted to talk a little bit more about was the registry structure before we dive into this. Because we're going to do registry structure. That's a sign of more coffee needed. Registry structure, and then we're going to do the lab Windows security, because we're going to dive right into looking at AutoRuns, which is going to take us to the registry. Cool. Okay, so registry structure. Going to be doing a little bit more iPadding for the beginning of this. And we're going to dive into the lab right after. Okay. Is that connected? Doesn't look like it's connected, yeah. I think we got out of sync. Yeah, I think it's out of sync. 1 second. Yeah, okay, cool. I think we're live, yeah? Class 24. Cool. All right. So we covered the registry a little bit before, and there's some things that I wanted to talk a little bit about again, and just remembering and refreshing before we dive into AutoRuns, and that to remember that the registry is effectively a database, if you will. Okay. This is Windows centralized store. Bearded saying the labs on the executable deal and threads was pretty and was hell goes in the background pretty cool. Yeah. This is where it starts to get more interesting. Like, okay, I'm getting under the hood and stuff, right? So essentially, the registry is one giant database of configs for Windows. Okay. Now, a lot of systems, software, services, ports, you name it, just about everything in Windows will rely on the registry at some point for some type of connection to query a preference or configuration setting to execute something. That's just how it goes. Now, remember that there are essentially 5 main root key hives, right? So we're dealing with, over here, we have, there's HKLM, right? Local machine. So what do we have? We have HKey local machine. We have HKey users. Classes root, classes user. Classes root. And HKey current config. So these are important things. It's not like you need to master and memorize everything in the registry for where you're at right now as an analyst. Generally understanding what these things are doing and why, and more specifically, there are 2 that we want to pay attention to, are the run keys, where things can get executed automatically. So just as a little bit refresher, the HKLM will store like your OS wide settings, drivers, systems, services, and such. Okay, your local machine. Now, the users actually will provide 1 subkey per user logged on to the system. And that's important to remember. And it's actually in the form of an ntuser.dat file. Now this file gets created and initialized when users are logging in. So this is why when you see like a domain user is logging into a workstation inside of a regular domain network, there's that initial screen like profiling, creating files, and it creates like the user folder directory and their preferences, etc. along that way is going to create another subkey for a user logging in. So unless the user has specifically been to that workstation before or logged in, it's not like they're going to be having a hive for them. So that's important to pay attention to, because when other users are logging in with certain permissions, it's going to initialize a subkey for them. And this is where you get things like the result of lateral movement. Lateral movement at a local level is going to happen from other users that have authenticated to that workstation. So that's something to keep in mind. Miss Valentine, welcome. Good to have you over here. So keep that in mind. Now, we refer a lot to like HKC, like the current user, right? So this is what happens when, say like you open up an email, you download something, and you open up like an Excel file. This happens at work, right? And then someone freaks out, like, oh my God, I opened up an email and I downloaded something and I don't know what it did. Well, it could have actually put an entry inside of the registry, and that's going to go to the current user. So when the Windows operating system boots up, you've actually got a series of events that happen. One of them is going to be querying these things called the run keys. And that's what we're going to be looking at today with AutoRuns, a simple tool to validate and verify what's actually happening in Windows. Like, what is Windows starting up when you start it? And I'm not talking about opening up like your startup items. I mean everything, like really getting under the hood. And I think if you can do this, then truthfully, you can probably perform an analysis on your home machine at home. Like after today, you can go and use AutoRuns, take a look at it, look at your workstation at home, like your Windows computer, and see like the services, the scripts, script files, like bash files, anything that could be firing up on startup is very easily visible with the right tool. So we're gonna take a look at that. So like I said, so HKCU is actually going to be pointing to this, the current user. So I'm not sure if you noticed that before with the registry when we talked about this in the past. But not everything in the registry is real. Has anyone here in the chat heard of symbolic links? Take a wild guess. I know we got our no CI. Zeno, yes. Karina, yeah. Demoria has, yeah. I was just thinking of that. Karina was just thinking of that. Of course you were, Karina. Yeah, every time. Karina's always on the investigation. Always connecting the dots. Tom, no. Jordan. And Linux binaries, yeah. Often using Linux. Yeah, cool. Okay. Yeah, DevOps, nice. So the only two hives, I should say, that are real are these two. The other ones are actually just symbolic links. Now what that means is that they're actually just alternate paths or references to the original data. And this is because of just like general optimization. If you wanted everyone to reference a single object, you would want shortcuts to that. You wouldn't want to go and create multiple copies of the original and then share that around. That can create a problem. So it's actually more preferable to go and have a single destination or a single source of truth and then point at that for everyone to reference. This is commonplace in everything in Windows. When you have, like, if you open up your start menu or your desktop and you double click like, I don't know, like a game, right? A lot of people are playing Marvel Rivals these days. You double click that shortcut and you fire it up. It's a shortcut. It's like you're not loading the game right then and there. You wouldn't want a copy of the game on your desktop in another folder as well too, for wherever you need to point at it. You'd have a single location for it, and then you'd have shortcuts that point to it. The hives are no different. So that's just something important to keep in mind. Now, there's two of these specific areas that we want to pay attention to inside of cybersecurity and IT, really. And we call these the run keys. What do they do? Well, hey, morning, Doug. They run things. Who would have guessed, right? That is what they do. They go ahead and they just run things. Now, they're going to be in two locations, pretty much. The two main ones that we're going to be looking at right now today. So HKLM, HKCU is where they can spawn. Now, what this means is we have one for local machine, one for current user. Okay? I think that's pretty self-explanatory, right? User specific. Yeah. So what does that tell you? If I were a threat actor, like, let's just think about this logically for a moment, right? What is a more ideal location? Where would I want to get my malicious startup script that dials out to another country, or my adversary infrastructure, taking all your data, sending it back, and uploading it? Where would I want to put my malware? Maurice says all users. Okay, local machine by Finac as well too. Interesting. Interesting. Yeah, that makes sense. Yeah, Karina, you want to go with both? Let's think about this from a threat actor level. Ariel's is onto something over here. Your initial thought was current user because then it could be used more immediately. Interesting. Does that change anyone's opinion now that you've heard another perspective like that? So we've got Demoria saying, if all users, then applications can run regardless of which user logs in. Get to you in a moment over their DevOps. Karina saying, I was thinking users for Demoria's reason. Yeah, all of them. So the question, Jordan, is if I was a threat actor, where would I want to store something malicious to start up? Do I want to put it in the registry for all users or the current user? All users. Finex got something over there. Jordan, I'm going to say depends on threat actor and his intended outcome, right? Right. Bearded. I mean, sorry, I thought it was KS for a moment. KS is usually on the gun of this kind of answers. Okay, so chances are, if anything, the malware is going to be able to hit somewhere in the current user first. And that's actually kind of where Finac is kind of leading us to. It's more about a permissions issue more than anything. If we have administrative privileges to get onto the entire system, like a local admin or something greater, then we're going to end up in the local machine. Remember what I said, that the hive is under the context of the current user. So if you download and you open up something, let's think about context, and you have some level of permission with your account, then what that's going to do is change your current user, right? So kind of going back up over here, we don't have access per se to all users at this point. When we log in, we are under the pretext of the ntuser.dat, which creates the HKey current user. Knowing that, chances are, we need to think about probability, right? We're looking for path of least resistance. We're probably going to see something pop up in current user first. Probably. And then we can look to local machine. This also gives us another thing to think about. That if we... Imagine you went to like a supermarket, right? And we had a full store of grocery shelves. And each shelf was like one stalker's directory, like one worker that worked there, like that was their directory, not their directory, that was their shelf that they worked on, and they stocked groceries and stuff. If we wanted to impersonate someone inside of that store, are we going to go and put our mark or our fingerprint, our thumbprint on every single shelf in the store, or are we going to go and add it to one? Where are we more likely to get detected? Think about that. We're dealing with adversarial nature. We're dealing with criminals, right? We're like a criminal mentality. Yeah. Right? You need to start at this point in the game, now that you're moving ahead, you need to start thinking and realizing that you're not learning how to triage malware based on the context of understanding like how IT works. You are trying to triage malware from here on out under the context of how a threat actor is most likely to perform their attack. This is a different way of thinking. This is not IT of like, okay, the user clicked on this, this is where it's going to go. That's not the game anymore. We've now started security work. We're now starting malware analysis. We're now starting Windows Triage. We need to start thinking like a threat actor. And I hate to say it, don't ban me, Twitch, but you need to start thinking a little bit like a criminal. That's what it is. Is like, what would a criminal do? Like, what is a criminal mentality of doing something to gain entrance or to gain execution or action on their objectives? What would they likely do? So, criminals don't like to get caught. I don't know about you, I mean, some do, but I think, and I'd put a wager on it, that criminals don't want to get caught with what they're doing. Right? It seems pretty apparent when you think about it like that. So under that pretext, under that lens, if someone doesn't want to get caught, what types of attacks and what types of malware will they launch and execute, and what will they do to you, right? Now, if they don't care to be caught, then whatever. That's going to happen, of course, too. But that's not the case more often than not. So under this lens now, knowing all this and thinking about it, we have our current user hive. Chances are this is going to be your first point of entry. Yeah, roll.bat, right? CI, so living off the land. A threat actor is going to try and use what is natively there. They're not going to go and... you know? It's, imagine you're going to go break into that supermarket. Are you going to go and, like, drive the truck inside of it and be like, all right, I've got my tools ready. Hold on a second, everyone. Let me just unload my truck, and then I'm going to lay out my tools, and then I'm going to use the tool of my choice to rob this store. And then I'm going to drive away. That's not going to happen. DevOps. So to succeed in IT or cybersecurity, you have to think like a criminal. Understanding how attackers operate is the only way to anticipate their moves, detect their methods, and effectively defend against them. You can't protect what you don't understand. True. If something pops up on everyone's computer, more of a red flag. Exactly. On one machine, you're probably going to troubleshoot some different things before assuming. Yes. Now, here, like, think about this even more, right? If you had 10 users, no, let's say you had 100 users, and you launched a phishing campaign, and then you just fired off this email to all of them. They all opened it up. Maybe like 2 of them, because the percentage is going to be like 2 to 4%, maybe a little bit higher even. 2 to 4% will open it, download it, and execute it. Now, chances are each one of those users is now going to report a different perspective of what's happening. My computer's slow. This thing isn't opening. Oh, this worked yesterday, but it's not working today. I can't connect to this web page. What do you think that's going to do to the IT team? Aside from, you know, giving them gray hair. Ariel's going to give them tickets? Yeah. It's going to give them work. They got work. Have you tried turning it off and on again? Yeah. Yep. And what do you think that provides the threat actor time for? Doing what they really need to do. Okay. So I think we've covered that enough. I think that's a good kind of like segue to start getting a little bit more technical again with this stuff, but I hope that makes sense. Now, I saw the question up there ahead in chat. Where was it? How to run and RunOnce keys work, right? I can't find it in chat, but it was somewhere up above. So there's a bit of a difference between these things. I should actually start writing this out. So we have the run keys, and then we have the RunOnce keys. So the run key is, well, every login. And the RunOnce is once. Now, interestingly enough, it actually also automatically removes the entry. So removed after execution. Okay. So now that I'm all training you to be criminals, apparently, knowing this, right, we have now these two forms of run keys in the current user hive. if I'm a threat actor, where am I most likely going to put my malware? Where am I going to put the bomb? Yeah? Ariel says run? In run for persistence? Interestingly. This is interesting. Okay, okay. Y'all are too good. You have halos above your heads. Doug. Is Doug here in chat? Yeah, Doug's here too, yeah. Create a run once. Okay, if I'm a threat actor, where am I going to put the malware? Am I going to put it under the current user run key to run every single time the user logs in? Or do I want to put it in the run once key where it's only going to detonate once and then disappear after? Slowly making you little red teamers over here. Slowly. I will get to the penetration testing stream later. We'll be doing some of that. Pen testing 101. Fundamentals. We're going to prime you. Finac, cover your tracks with run once as you are... yeah, exactly. How many times does it need to run to have effect? Just once. Just once. Yeah. If I am creating... If I'm thinking of how to break in, right? Persistence doesn't mean I'm going to drop persistence and then I'm done. GG's, right? Good game. I'm out. All right, cool. I'm on that shelf. You know what I want to do in the supermarket? I want to get on that shelf once, and then I want the stalker to go up to the box that has my item, and then take it to the back, and then get inside of the manager's door. I don't want to stay in the shelf. What's the point? What does that do for me? I'm under the context of the current user. Now, I may get lucky, and maybe the manager has a shelf out in the front of the store, and they're the local admin, and I landed on their shelf right away, and I'm good to go. But is that always going to be the case? What I want to do is I want to get somewhere in that run once key, and I want to see something that appears there. And I want that user to be able to reboot their computer or somehow get it restarted in some shape or form. Maybe I'm going to slow down their computer so much so that they're forced to reboot it, and then they're going to restart it, and something's going to run. And then guess what? That user's going to be like, hey, you know what? My computer's fine now. I guess I just needed to reboot my workstation. Yeah. Welcome to cybersecurity, right? This is a different game, like I said. Yeah, no one knows what happened. This is how a compromise happens. It's well planned, it's well thought out. It's how do I stealthily get inside here like a ninja, get to my objective, and then get out. So yes, probably going to see something inside the run once. And then you're going to actually see a form of lateral or vertical movement to maybe another user or to another software or another service. You might see something that will download and get to a run once key, execute on the reboot, but then hijack a process. Because remember we talked about the attacker wants to get to the runtime state. They might then hijack a process and it could get to something really bad. Because once they're inside at the process level, they may be able to arbitrarily execute code and then pivot to like the system account or a local admin account. And then they can start having some fun. That's when you can start looking for stored credentials and getting out. So you see what I mean? Like think about this like kind of logically. I want to get in the supermarket. I leave my fake item on the shelf. And that item is a regular store employee's shelf item. But it's something's wrong with it. So they're not sure. So what do? They take the item to the back room, which has a higher level of permission, and then once it's there, it executes. Damn. That's what's going to happen. So yes, this is like an adversary tactics type of analysis, like a tabletop scenario that we're doing here and thinking about kind of, we got to get in that criminal mentality for a little bit if we're going to be getting ourselves into cybersecurity and thinking like adversarially, like how do we defend a threat? So run once, we're going to be looking at that. Are doubles scary, honestly? Well, yeah, it is. It is. There was a question up there, though. Jordan's asking, can you see run once history and log? Well, this is why we have a SIEM. This is why we have log analytics that we're going to be looking at later. We're going to be performing log and event analytics. So you as security analysts will be looking at logs and events that record this type of activity. So remember when we talked about Procmon yesterday? And we're like, every single threat operation has an event? Yes. Every single operation has an event. You'll see that. You'll see like query, registry key, HK, current user, run once, add entry here. You'll see that when you run the binary that is malicious. So when a user downloads an email, fires up Excel, opens up that document, thinks they're fine, you'll see an actual process event. Now, in a security environment, that event is then piped over to a dashboard. That's all what happens. This is no different than in real life. If you wanted to secure your perimeter, you're just going to set up little tripwires with like a little bell. We've all watched a zombie movie and a zombie show, right? So when they go to sleep at night, they put like threads, strings with little bells all around the trees. And then when the zombies try to come at night, they trip one of those wires, makes a lot of sound and wakes someone up. Same kind of thing. There is an event for everything. Now, the difference with security is that we have bells on those strings alerting us what's happening. There is literally an event for every single thing that can happen inside of Windows. So the question should always be, what event log ID, what threat operation or process event can I monitor to observe this event? That is how your questions should be shaping from here on out. I want all of you to get away from the mindset of like, oh, is there a way that I can monitor this? Yes. And then your follow-up question should always be, and you can Google it, because I don't have like every single answer in my head. I don't have every single Windows event ID mapped. That's impossible. We talked about that. Your next question should be, okay, where do I need to go and research or look online to find the event ID related to this type of event? Or where do I need to go find a process operation event related to this type of activity? Does that make sense? Ariel saying, what about shell bags? Something I would leave trace registry. Yeah, so Ariel, same thing. Same thing. Yeah. Remember what I said yesterday with Procmon? Like, unless you've hijacked Windows, there's no way in hell that you're going to be able to like disable a Windows event from happening. It's part of the operating system, and if something is compromised at that level, you've got like a bigger problem. Way worse. Way worse. Let's take a look. So where are we tracking right now? Make sure we're on point. It's 10:52. Okay, so I think that, where are we on the, get the iPad out of the way. So I think that's enough to cover registry structure. Let's go and take a look now. Let's actually go and look at this. So we're going to go take a look at lab Windows security, and we're just going to look at some tools. So we've got a couple to look at over here. AutoRuns. We've then got to go take a look at Sigcheck. And these are free tools. You can go and download sysinternals right now. TCPView, and I think that's it, right? Yeah, okay, cool. Bearded Ruckus. Would that malware you described to be considered a logic bomb? Yeah. I mean, I don't know. I wouldn't... I guess you could classify it as such, but truthfully, a logic bomb is, well, a bomb based on logic. So, like... Yeah, like time-based, action-based, event-based. Like, technically, yes. Technically, yes. Now, I think more like... More realistically, logic bombs are probably more related and referenced to as... Like, I would say, like, overwriting or deleting files. Something really dormant, and not so much like in Run and RunOnce. Because, yes, a startup script as a persistence mechanism could be considered as much, but I think I would classify that just more along the lines of, like, a persistence mechanism of the overall malware itself. And not so much just like a logic bomb. You know what I mean? The logic bomb is more like the final thing, right? Like when the bomb goes off, there are no further steps. Right? Like if you go set a bomb and it blows up, that's the end. That's the end of the event, right? So think about it under that context. So like something that is like a deletion of files after an event, or preventing access, changing a service state or a firewall, like the final event of it all, I would consider more to be like the logic bomb itself. Nuclear guy, thanks for the follow. Left Eris 94, thanks for the follow as well too. Kind of missed you back there. Sorry about that. Also Noise Silence, missed all three of you. Thanks for the follows, everyone. Thanks for the support. Yeah, cool stuff. Yeah, exactly. Like Doug's saying, it can be contained within something else. And to that end, you know, like a logic bomb relying off of normal Windows operations, that's what I'm saying. Like it can be classified as much, but it removes the meaning and the essence of what the logic bomb is. Like a logic bomb is like you want the user to do something that is intentionally designed. Like maybe at 4 p.m. every day, that user opens up their timesheet to add like an entry. That's where you would put the logic bomb, because you know, like that is a user specific action. They open it up, boom, it deletes all the files. What are you saying in chat over there? Running once can salvage. Karina's saying, wondering how run once can establish persistence, though, if it is removed after execution. It was written to be moved laterally. Ariel is saying, yes, exactly. Yeah, the intention is, you know, the bomb is going to go off, but as it happens, that's the intended design, and then something happens somewhere else. Yeah, that's what I was saying, Karina. Yeah, the backstore. Cool. All right. Cool, we just capped 1,400 followers, which I think is inflated, because I remember there was like a bot invasion that had raided our channel earlier on. It gave us like a whole bunch of followers. But cool, we're at 1,400 now. Nice. Yeah, good, Karina, so you're tracking. All right. So let's go and let's actually load up the lab Windows security. I'm going to fire up the Windows workstation, and we're going to look at some basic tools that any security analyst, or even yourself at home, you could use these tools at home, and you could get an immediate understanding of like where things could go wrong. The first one's going to be a tool called AutoRuns. And it's called AutoRuns for a reason. We just talked about the Run and RunOnce keys, right? If I told you to use a tool like AutoRuns, what do you think it's immediately doing? Nuclear guy, will the stream be saved? Yeah, every stream is saved. And then I start to upload them on our YouTube on the Monday, Tuesday, following week. Yeah, Bearded's showing running. Yeah, showing the reg keys. The name sounds like it's running automatically in the background. Oh, man. Okay, so AutoRuns as a diagnostic tool is effectively just this. It takes a snapshot of all the various ways that you could have things start up with Windows. That's it. So we see things like auto-run entries are included inside there. What else? Maybe extensions, browser objects, right? Like we have browser objects, scheduled tasks, services, drivers, DLLs, all those things that we talk about, right? Yeah, Kim's saying showing everything that runs automatically. Yeah, it's everything that runs automatically. So while Windows is loading up over there, nice, it's connected now, cool. Cool. Let's fire it up. Let's take a look at AutoRuns. Yeah, loaded, cool. Okay, so it's on your workstation already, and if you don't have it, you can go to Google, type in sysinternals, download, and go to the Microsoft website, sysinternals suite. Put that inside a chat. You can download the whole suite of sysinternals tools. You can see all of them over here. We've looked at, where is it? Process Monitor, right? So we've looked at that already. And then we're going to look at AutoRuns next. Now, we train you more so to be like tool agnostic. So we train you on methodology. Like that's why I'm walking through things like the registry beforehand. I'm not just pulling up AutoRuns right away and say, hey, look at this and look in this tab. Now that you know more specifically where to look for Run and RunOnce keys, it doesn't matter if you use AutoRuns or like Doug's famous malware checker 9000 or Kim shows you're not fried with malware software. Just calling your names in chat. It doesn't matter what tool you use after that. You know at this point that you just need a tool to look under the registry, under that context, to see what's loaded there, right? I hope that's more clear. You could just open up the registry editor and go to the registry key yourself. You don't even need to use AutoRuns, but we're going to use a tool like AutoRuns to make our lives easier. So start menu, entry, type in AutoRuns, and let's fire it up. Now, the beauty about these sysinternals tools is that they were designed like purpose-driven. So Process Explorer, right? It is designed specifically to do a few things very well. It is not meant to be an everything tool. AutoRuns. It is designed specifically to be looking up any type of entry on your workstation on Windows that will show you what will load automatically at some point. That's it. Bearded. So an attacker can do a sweep of what ports are constantly opened to determine what applications are constantly running or is auto-running a startup. The attacker can place the malware strategically in an app that auto-runs. Effectively, yeah. Yeah, exactly. Good. Your criminal hat. You just leveled up. That's 100 experience points for you right there. Unlocked a little bit of a class tier. Yeah. Good job, man. That's the only time I'll condone and approve that. You're not thinking like a criminal. You're thinking like a threat hunter, okay? That's the better context to think about before I get reported. Okay. So here's AutoRuns running. Super simple. You have your everything tab, your logon tab. More specifically, right? Like look at the top over here, the AutoRuns entry. What do you see? Local machine, you have there, and there are more things. Like the Run and RunOnce keys we're just kind of getting you started off with, but there are a lot of different ways that an auto starting mechanism can start somewhere. So we see startup entries, we see available shells, and then inside of Explorer itself, there's something that's starting up as a column handler, and you can see, right, the image path, it's loading this DLL. Beaver Logic saying, to be honest, these are trivial things that the OS doesn't find. Yep. This is the basics, right? Like this is like your tier 1 analyst type of thing. You're doing like your initial triage checks and stuff, which, I mean, I've met tier 1 analysts that actually don't know how to triage a persistence mechanism in the registry. And I mean that. It's not ideal, but I have met that. So again, we're going to look through like all these tabs, right? So if we ran an Excel file that we downloaded, first thing we're going to do is use a tool like this, like AutoRuns, or a tool that examines entries like AutoRuns to get this information. So what do we see, right? Like scheduled tasks, services, drivers that are loading, codecs, etc. All these things. Windows management interface. Yeah, instrumentation. Yeah, I think so. Network providers, print monitors, you name it. Now, what we can do to top is we can actually go and you can hide some views for you, right? Like if we wanted, we could uncheck a bunch of stuff and go back to everything. But now, like, this is insane, right? If we said don't hide Microsoft entries and don't hide Windows entries, boom. Like this is way too much. So what we can do is we can click these things at the top or go ahead in the options section. Hide empty locations, hide Microsoft entries and Windows entries. And now this list gets a lot more manageable. Generally, the other entries should be fine, but in an official environment, you'd have things set up to go and inspect for changes and threat operation events that maybe like queried these things and changed them when it shouldn't have. So what we can see here, we can see a bunch of things that aren't verified, right? So like this is the npcap watchdog. This is actually installed with Wireshark. So you're going to get things that are flagged at you with this red highlight. And you can see like this is not verified. And we can see the startup entry. It's at C program files, npcap, check status.bat. We could do a check VirusTotal from here and do an online check. Submit file to VirusTotal. We could also go to jump to image, which will take us right to it. Let that load. So we can see right away, so we don't have to go and sift through the file explorer. It can take us right to it. So if we saw a script running here of like, haha, evil malware .bat, we'd see it here. It would be flagged as red, and then we can go to it as well. So, I mean, like, that's AutoRuns. Really straightforward. And this is, we're going to get you to use this when we actually start running some malware so we can develop the basics of our triage skill set. Make sure I'm tracking over here. 1107. Okay. Cool. Now what we can also do is we can save a snapshot. So you can like write a script that takes an AutoRun snapshot of your environment like every single day. And then you can compare it. So if we did a file compare and compared it to the snapshot of our system, well, you just have, there you go. Like there's your baseline. Like yesterday I trusted Windows. Cool, I'm going to snapshot that. And now I'm going to write a script every single day that compares my original snapshot, excuse me, to the new snapshot that I took every single day. And there you just have a really robust security control. And it didn't cost you a dime but your time. This tool is free. Next, we've got Sigcheck, which, well, signature check. So we can take a look at this, and pretty straightforward. If we run Sigcheck, it's already built to the command line because we've installed it. We have a variety of options we can do over here. So like just for intents and purposes, let's run signature check. A couple flags over here. Let's just run it on. Is that too small, by the way? Here, let me make it a little bigger. There we go. Do program data and chocolatey bin procxb. Bin procxb 64. So take a look at this. So we covered hashes in the cryptography section. We've looked at it already. So we can run a tool like Sigcheck and get a full set of our hashes, signature, signing, etc. Full extended information. So if we found an entry inside of the AutoRuns directory, or sorry, the AutoRuns tool, and we wanted to examine it further, you could use a tool like Sigcheck to get more information on that binary or that script to find out, okay, well, what are the hashes? Then you can run these hashes online, these little signatures and fingerprints of the file, to see if anyone else has found something like it before. Some version information, the architecture, etc. So another tool in your toolkit. Now, another tool in your security toolkit would be TCPView. TCPView I like to refer to as like the visual representation of running netstat on the command line like all the time. So nice and handy, really. So we can go at the top. We can choose the protocol we want. Like, do we want IPv4 or IPv6? And listen to TCP or UDP protocols. And here we can see now all of the network activity going in and out of our system. And that's so much easier, right, than netstat, which has its own purpose, of course. But if you're doing an analysis of a binary or a compromised workstation, we now know we can use AutoRuns to see if there's a startup entry that's sticking out to work like a persistence mechanism. We also know we can use Sigcheck to run it against whatever we find to look for hashes and then compare that online for other types of intelligence, see if someone else has encountered it before. And then we can use a tool like TCPView to see if anything's beaconing in and out. Now, we can also go inside of the View tab. We can change the speed as well, too, of TCPView, which is really helpful, right? We can change it at the interval of like 1 second, 2 second, 5 second to see how things are changing. And obviously the states change. They're all the same, right? Like green, new, red terminating, yellow, paused or established or waiting for something. All these tools work very similarly. So you have these visual indicators, these visual cues for you to immediately see what's going on. You can change the protocols that you're interested in listening to from here and not just the tabs at the top. And then most importantly, the connection states. So if we were looking for, we covered a little bit about like TCP activity going out, like I don't know, like if there was someone trying to perform a brute force attack on an account, well, what would we be looking for if it was a TCP protocol, maybe like SSH, right? We'd be looking for things along the SYN and the ACK side of things and see what's actually happening here, like where are these new sessions? So if I open up a browser right now, and what I'll actually do is I'll compare this 1 second. I'm going to show all protocols for a moment while that's firing up. This is what happens when you click on Edge. Cool. All right. See, like look at this. I open up the Edge browser, and look how much crap just like appeared on the screen. Like, look at everything that's happening just on opening up the browser. Crazy. Now, I can resolve these addresses as well, too, by clicking the little tab here at the top. So we can get an idea, like, where's the remote activity going out to. And wouldn't you know it, just like a whole bunch of, like, ad tracking stuff, right? Google content, images and things that would be downloaded. But here you go. Like, you can immediately see what a process would be doing at the network level from here. Similarly, right, if we went to the proc XP tool like we looked at yesterday, let that fire up. So if we look at like, excuse me, if we look at like the parent process for MS Edge, you can get an immediate look. Beaver, I see that. Beaver, I haven't set up a bot yet. Sorry, I need to get a bot set up or something you can query those things. Our Discord, there should be a link under though the stream, right? Do you see that? Let me grab it. Yeah, you got it? Okay, cool. All right. So yeah, so if we looked at like the parent process, right? We can see the TCP activity happening over here. But then, of course, there are the individual threads that are happening, or sorry, the individual child processes that are executing underneath the parent that are all doing their different things. Some of them have more activity, some of them don't. But that's a little bit confusing to look at from like an individual level, right? Like you're doing a lot of clicking. TCPView is really handy that you can have something up at the same time, and you can pause it as well too, hitting the space bar. But now we actually get a full glimpse of all the activity of that binary and what it's doing. So super cool. You now have effectively 4 tools that you can look at to get the full scope of persistence activity, process activity, and networking activity. And I hope that gives you some confidence before we start to build that confidence even some more. Because now you actually have some tools where you can go and examine and perform some level of immediate defer. So you can perform an incident response to whatever you download and click on with these tools, like right away. You also get a little bit of forensic activity to see what's on the disk and what things are actually doing and piece together an investigation. And then, of course, if you want to get deep and under the weeds, fire up procmon as well. And let's just reset all this. Process name is what? msedge.exe. Oh, whoops. Remove that. .exe. Apply. Okay. Clear that. And then there you go. Boom. So let me shut down Edge right now again. Man, it's so slow. What a bloated browser. Close that. I'm going to clear my procmon. Wow, is it still running? I thought I closed it. Let's close it again. Okay. Clear. Yeah, nothing else is running. Okay, so now let's open up MS Edge. And then we are filtering for process-related events that are happening at the thread operation level for anything under the process name related to MS Edge. So we can see the process start entry we talked about. We can see the thread has been created. Need some water. We can see that the image has been loaded. The DLL file has been brought into the thread as well. At this point, we see, what do we see here? Registry keys that are being queried and opened and values being worked with. So here's that reference. We have a whole bunch of local machine and configuration settings that are being queried by the MS Edge process. And we also have a full snapshot in the TCP view to see what the MS Edge process is actually doing connecting out to you at an IP level. And then inside of AutoRuns, if we ran the binary, we could refresh this and see what actually happened. And then at the Process Explorer level, we now have the MS Edge process that's running. Take a look at the runtime state, and we could perform some analysis. Like if this was malware, right? We could look at strings, and we could look for anything that's sticking out of here that's like immediately discernible. If there's some type of malicious code, we can see the permissions that the binary might be working with, and again, the TCP activity, and what all the individual threads are actually doing and querying. You have a full security, digital forensics, and incident response toolkit for free with these tools. Jordan's asking, AutoRuns, Sigcheck, TCPView, and ProcXP, and Procmon T-Aerial. Yeah, guys, don't forget about Procmon. Procmon is huge. Because when we're trying to write like detection rules, like we're looking for things like this. Nice. So good. That's right. There you go. Okay. I think we're ready to actually look at our first malware called the AutoRunner. Pretty slick name. That sounds like some pretty slick malware. Right? Okay. Let's take a little 5-minute break. Refill the coffee. Always need more coffee. Stretch. Get the legs moving. Yeah? Jordan saying it was just about as the break was. Yeah, I know. It's easy to get like into this, right? It's so easy to yeah. Okay. Well, let's take a fiber. All right. Cool. Everyone got their coffees? Just water today? Fair enough. Give everyone a minute over here to get back in. Jordan, just water, 3 liters of water and 3 liters of coffee. Exactly. Well, half and half. R double, yeah, fresh coffee. Coffee. CI, you're doing intermittent fasting. Nice. Good for you. I need to do another fast soon as well. Maybe, I don't know, this week or next week. Go for a nice 24-hour. Good for you, though. Yeah, it's amazing. Jordan, you're on a bulk. Finish in a few weeks. Yeah, I know, right? Miss Valentine, heading to the gym. Cool. Yeah. You're gonna miss the actual malware now, though. But thanks for coming by. Enjoy the gym. Go crush it. And we'll see you later. Black coffee during the fast. Yeah, I do the same. RW hit the gym before the stream? Yeah, nice. Yeah, the streams are a little early, like for me. Starting at 10. I think I'm gonna move them a little bit later so we can all sort of accommodate. I think like the consensus was like a 12 to 2 kind of like educational stream was enough from the survey. It seemed to be the majority ask. But probably switch going back at that point. I like early morning gyms myself, because I'm working on like the afternoons and evenings now. I don't really prefer it. So yeah, once we get more to like a 12 to 2 kind of cadence, then yeah. R double 79, nice. Candle black coffee. Yeah, it depends, right? DevOps time is okay. Yeah, it's not bad. It like everyone likes from what I've seen in the survey as well too. Is everyone likes the time and they like it, but the overall preference is for I mean after SOC 100 of course, because we have a lot to cover, right? But I think after that we can get to like the 12 to 2 kind of time slot, and it's just more focused because we're on a cadence right now to go through the entire course, entire training. But cool. Okay, so let's actually take a look at our first sample malware. We're going to be looking at the FNAC 12 to 2 is 12 a.m. Oh man, are you up right now? Like, don't dox yourself, but damn. Night owl. Okay, let's open up the Foundations lab data folder, and let's take a look at the Windows Triage and Malware Analysis folder now. So we have 3 sample starter neutered malware, defanged, like nothing bad's going to happen. It's just for you to learn the tools. The first one we're going to be working with is the AutoRunner. Now I think you can get an idea what this one is about to be covering, but this lab is about learning persistence, kind of like working through it and having a nice easy segue into seeing what it does. So, well, let's fire it up, right? I'm going to close up Edge. I'm going to close up all my stuff. Like imagine you were just like at home, you ran a file, you freaked out, didn't know what happened, so I'm going to close everything. I'm going to double click it. YOLO. Let's fire away. See what happens. Okay. So, not sure if you caught that. But, so as soon as I ran that, something else popped up and it said, nothing to see here. Now take a look at this. Startup app notification. Roll is now configured to run when you log in. Well, there you go. So this is why you have Windows virus and threat protection. You can't catch the AutoRunner. Not you or anyone. No one can. Okay, so clearly something bad happened, right? Clearly something bad. Clearly something bad. Now, what happened, though, right? That's the question. So, like, let's take a look at the Windows startup, or rather, sorry, the Windows virus and threat protection, which is honestly pretty good. Let's take a look and see what it says. Roll is now configured to run when you log in. I'm going to double click this and see what it's saying. All what it says here is rolled with a blue square and on. Now, what if this said something like Windows security update and someone ran something, right? Or what if there was no notification? That's where it starts to become a little bit more problematic. What if this had evaded EDR and AV? So let's take a look. This is where a tool like AutoRuns comes into play. Let's fire it up and see exactly what happened. Okay, so right away, we can see in the HKey current user software, Microsoft Windows current version run. What do we see here? The AutoRunner was here. Not verified. So we have a couple things we can do. We can jump to the entry. And if we jump to the entry inside of the registry, we can see the key and the value that has been declared by this malware. So it's saying the name is the AutoRunner was here. So that's the entry of it inside the registry. So if we were performing like a forensics investigation right now, right, we're going to start cataloging a lot of this. Okay. Oh, man. Okay, let's go ahead and do this. So, registry entry format. Let's do a little bit of word wrap. This is pointing to roll.bat. So we can go back to over here and jump to image. So this has actually been, this was written to the C users administrator folder. It's a batch file. Cool. Now let's take a look. I'm going to actually open up PowerShell, see what's going on inside here. So I did type roll.bat. Take a look at this. Bat, yeah, it's a batch script file, CI. Yeah. So start Microsoft Edge, HTTPS, YouTube, watch. So this is the entry. So when we start up our computer under the current user, this is going to run every time. Not run once, but this is the run key. So this is going to run every single time. That's what this is saying. Now, we can do a couple things here. Let's go ahead over to VirusTotal. Right? Head over here. And let's go and drag in. Like, let's just say we didn't have full visibility into what the file was. Oh, man. Trying to drop it inside of there. It's not letting me. 1 second. There we go. Cool. So we're going to run this through. It says roll.bat. Look, it came clear though. So detection rules said that this is not malicious. Now let's go and take a look. Go to PowerShell. Let's go see what this is. So we got a YouTube video for us to go and watch. Sign in to confirm you're not a bot. Well, it looks like this would have been a RickRoll video. So it looks like this malware was configured to be executed, and every single time we would start up as this user, it would actually put us on a RickRoll. So 0 entries in VT for malicious activity. RickRolled on startup. So it looks like this malware is actually just trying to RickRoll us. Now, what if we couldn't do that? What if this was another link? So what I'm going to do is I'm going to open up another browser. 1 second. And I just need to log in here separately to my Any.run account. And we can actually sandbox this link. Just give me a second to log in here on the side. Cool. So we'll go inside here and let's submit a URL. So I'm going to go back inside the Windows workstation. Right click this, go inside here, we're going to run this. Run inside of public analysis. I agree. So let's take a look. Let's see what the sandbox tells us. Yeah, I know, Doug, that's what I'm saying. Yeah. So like, yes, clearly it's a YouTube link, but what if it wasn't, right? So now we have something like this amazing tool. Let's do reject all. Filled end, thanks for the follow. And thanks for... Cool, yeah. Thanks for the little shout out right there. It's all good, man. None of us know everything. And you can always kind of catch up and learn as we go. So thanks for being here. Cool, so it looks like we ran this through a sandbox. And we've got Any.run was able to process the link for us. And take a look. So this is actually trying to run this. But again, sign to confirm you're not a bot. YouTube's never ending. They really want you to be logged in and stuff. But if we knew, if this wasn't a YouTube link, this is what you would do. Okay, so that's just to be 100% firm on all that. So now we have actually like a play-by-play of what happened over here. Like the GET request happened, and then it was able to let us know that YouTube link piled up. Filled end, am I pen tester? By trade, yes. Yeah, that's what I specialize in. I consulted and I pen tested for a number of years and red team a little bit. So, yeah, pretty cool. But those would be some of the steps that we want to process. So, okay. We'll go back inside here. We got our little forensic notes, right? Ran the link through app.any. Yeah, app.any.run. Go inside over here. And we can actually go, we can share this link, right? We can go inside here now. And if we wanted to record this on our digital forensics investigation, or give a report to someone else, like if we wanted to upload this to VirusTotal, we could say, well, here's like an any.run link, and you can actually go and watch what happens when you go to that link. So, yeah. Jacopo saying, is Windows Sandbox safe? Are there any differences between it and... I don't know what the link was there. Let me make you VIP, man. 1 second. VIP. IT. Jacopo. cool. You should be able to drop links properly there now. Yeah, so, I mean, look, Windows Sandbox is going to be generally safe, but I would always recommend, as much as possible, like, don't do that on your home system. Don't do that at all. If you can run it through like Joe Sandbox or app.any.run, anything like that, that'd be more preferable than running it through your home workstation. Yeah, something like Doug's saying, something you can blow away. Who's your daddy? Zig versus C, who wins? C. But that's more of like an it depends, but I'm going to go with C. Just for general compatibility, legacy support kind of really like getting under the hood. That's like as low as you could really get. And there's a lot of like generally like old stuff that was configured as well too. Zig's cool too though. Nim is also pretty good. Pretty big fan of Nim. Phil Den, so you watch plenty of hours, but other pen tests are super cool. Yeah, man. Well, welcome over here. So, we're actually more of like a defensive tradecraft platform. We're more about the blue team and defensive tradecraft oriented disciplines. So like defer, malware analysis, reverse engineering, SOC analyst, triage, security engineering, more on like detection engineering side. Yeah. No need to defang it. I mean, you don't want to defang it, right? Like if you're going to run this through an isolated lab environment, like if I want to put this through any.run, yeah, I don't want to defang it. I just want to go nuke that thing. I want to let it blow up. R double, not even in a VM. Again, it's more about like your general risk profile. There are VM escape vulnerabilities as well too that could permeate and get outside of the virtual machine. You have to remember when we talked about the kernel and user space, right? Like this virtualized environment at some point it still has to be, if you're running this as like, if you're not running this as like bare metal hypervisor, and even then like there's still the problem, like something could get out, right? So it's just more about your general comfort level and your risk profile. I always recommend, if you're going to run any type of malware, you're going to run it through another system that you're okay with completely blowing away and isn't connected to anything at all. That's more of the recommended advice. Yeah. Filled end. I don't use a PC much nowadays given recent development and visual impairment. Sorry, man. Sorry to hear that. But you're curious about, since you're talking about Windows, tell me how bad Okay, well, Copilot is good for the sense of it being like an AI assisted tool, but like anything, telemetry. Like, yes, any type of AI assistant, as we start to roll these things out, is going to... it's going to improve your experience. I would not be running malware. I would be very careful about what data you're processing through an operating system that has an AI assistant tool at this state in time. It's still a very new developing technology. And I think there was actually something recently with Apple's. I think I need to... I haven't caught up on that. I saw like a thread somewhere, like the Apple summarized summaries of like your activity, I think was messing something up or revealing something. I'm not sure, but yeah. Defanging it as well too. Yeah, so like defanging it in the sense of when you're ready to perform like a full forensic analysis of it, you obviously want to take out any of the IOCs or comment out markers that would lead to something bad, because you know what they're going to do. So you don't need to compromise your workstation or go to anywhere that you shouldn't go, especially like if it's some type of public activity or the web, places that you don't want to see. Like that's what it means to like defang malware. So what we're doing here with this example malware, so the AutoRunner is like a simulated defanged malware. Like there is an IOC, so there's an indicator of compromise of a link that was associated with a batch file script called roll.bat after you reboot. But clearly it's a YouTube link. However, for all intents and purposes, what you're going to want to do is actually go and run this through a sandbox. So that's why we're also demonstrating that too. So yes, like it's fun to kind of laugh at it as we go because we know what it is. But if you have a link or something that's going to take you anywhere or anything truly, like you should be running this through a proper sandbox. Yeah. Karina, so you register new. Karina, I'd say reach out to them again. Like I don't see why they wouldn't help you out. Or maybe try a different email address. Or just try like Joe Sandbox. Chaos. So what's your system that you use that you're okay losing? I have a variety of them, man. Like I've got a Windows, Linux, and Mac environment that I can blow away for independent research on whatever it might be. Finac, are your recommendations of running malware and disposable hardware the risk of malware escaping the virtual environment? Yeah, pretty much. It's not like you're going to have the time to kind of go through and get a full forensic analysis of what the malware is always able to do. Now, if you're just kind of teaching yourself in your own home lab, it's probably fine, but even then, not. Like if you go to like Malware Zoo, right? So you've got a ton of malware over here, like a ton. You can see in the stream, right? Yeah. Like here is a ton of malware for you to analyze, but this is live. Like this is actual malware. This is not stuff that you just be like, oh, I'm just gonna like load up like a Windows sandbox, or I'm just gonna like run this on my machine and then, oh, whatever, like it's just gonna be in a virtual machine. No. Like this, some of these things will try to traverse your network. This is where it gets more complex and complicated. So you want like a very isolated system depending on how deep it's gonna go. Finac, is it okay to run something like Flare VM's virtual machine, a laptop that does not have important? It is, but again, just consider the network impact. Like, is that laptop also isolated on the network? So it's not just about the virtual machine itself and the laptop, but is it on a subnet? Does it have VLAN separation? Is there a firewall in place? Is it separated and out of reach that devices can't speak to it? Because if it is, then good. And if it isn't, just be prepared that if you run something there for malware analysis, it could get out. This happened to someone I know that they fired off a ransomware malware for analysis, and they still had the network connections opened up, and it actually went off to other virtual machines in their stuff in the network. Who's your daddy? During an IR incident, you find obfuscated PowerShell script running on a compromised endpoint. How would you reverse engineer without running in your environment? Well, I mean, if it's a PowerShell script, it can't do anything unless you execute it. So first of all, isolate it somewhere, and then just reveal the contents. You can do that a number of ways in a code editor or whatever it might be. And then just go and inspect. Look for decoding. Look for layers of encoding, layers of obfuscation, see what it's trying to do inside of it. As much as you can deobfuscate, the better. Chances are there's going to be some type of obfuscation, whether it's base 64. You're going to see the usual, like a PowerShell invoke expression, like things like that, right? Like all the usual PowerShell suspects that you would see. Look for any types of like Windows command, no, I shouldn't say API, but look for any types of like commandlets that might be fired that could interact with anything at the system level or like Active Directory, and do your own analysis of it, and then run that through a sandbox as well too, where you could actually go, like, imagine this was your sandbox, like go inside and try to run this script over here afterwards, but before you do, have something like procmon up and running, where like process.name is a filter for whatever that's going to spawn, and then have Process Explorer running, have all that stuff running, right? So if you're like a tier 1 analyst, like that's what you're going to do. And then if you're more advanced, well, obviously you're gonna have like, if there's a binary involved in it, then you're gonna have like a debugger up and running and seeing what else is going on too. But I think through that you should get the full scope of what it's actually doing and look for like parent-child relationships. Karina, basic question, Any.run sandbox because you can run malware safely. Yeah, it is a sandbox. It's also not in my environment. Like this is hosted somewhere else. So like that PowerShell question from Who's Your Daddy? Well, I would try to get it through something like this or something like Joe Sandbox and see what it could be executed with. So go over here, run the sample and upload it, and then actually see the live interaction. This is, of course, if you don't have your own home lab. This would be a great step for anyone to do, just trying to run the script or the file inside here. And then if it looks like it's okay enough, you could bring that into your own home lab and then do some further analysis. Sounds like Aliens movie, yeah. What's that link you showed up, Abe? Oh, cool. Nice. What is that? Any.run cybersecurity. For non-business email users, use the verification channel. Oh, okay, nice. That's a good tip, man. If you don't mind, please share that in our Discord as well, too. I didn't know that they actually have that there. Karina, very basic question. What is Sandbox? So a sandbox is just a virtualized environment that is completely cut off from everything else. So imagine like the playground at school. You had your school, the park, and everything around it. And then inside the park, there was a wooden sandbox where activity happened inside of it. And there was a clear separation with that wood barrier around it. Like the sand didn't touch the grass didn't touch the sand. Once you were in the sandbox, you're in the sandbox. Nothing that happens in a sandbox can get out of the sandbox. That's why they call it that. Zeno, turn off networking? Yeah, I mean, yeah, 100%. Turn off networking if it's not already disabled, then you don't need networking activity. But what's my thoughts on CubesOS? I haven't used it. I don't have any real thoughts. I haven't really investigated it further. I've heard a lot of people talk about it. But good. Who's your daddy? So, not going to start getting into like tabletop scenario after tabletop scenario, but because we definitely need to get moving over here. Already at 12. We got a couple more things to do over here. But so an attacker modifies Windows event log to erase traces of their activity. I mean, that's kind of common. You're going to see logs be deleted in some shape or form. So something like shadow copies would probably be interacted with as well too. So that's something I think you would want to look out for. I think you would want to look for any leftover event logs that says that the event log was cleared, because you're probably going to see that as well too. That's kind of like a mistake. I think also if you're in a proper environment, you're going to have logs that are shipping events and like Procmon related events all the time of things like that would capture the erase of it actually happening. And then I would try to figure out, well, what, like when that occurred, what happened before it? So it's just a matter of putting like a chain of custody and performing an investigation and putting a timeline together. So did we have a change in the baseline at any point for some type of initial entry? Was there any sign of activity related on that user account for lateral, vertical types of movement or permission escalation or service changes, etc.? And then when the event log happened itself, what happened afterwards? So it's just building a timeline. That's really it. There's a ton of forensics you could do. The question doesn't have a lot of context. I'm just kind of like shooting as a step-by-step over here. Memory, disk forensics, like you name it. And just really at that point, was there any network activity that occurred after that, right? Because if we're looking at like some type of action on objectives, was there a beacon out? Was there a download? Was there an upload? Was there a protocol misuse? Who knows? Hard to say, man. But yeah, cool. Okay, so let's keep going. Did we finish the lab? I think we did, right? Yeah. Let's go clear this thing out actually. So now that we know what it does, let's go and minimize some of this activity. Now we can do a couple things here, right? we could go and we could just go ahead and delete this thing. So the AutoRunner was here. So let's get rid of that registry entry. Do a refresh. So now this is gone. But remember, we also had the roll.bat script. So this is still on our system. And if we were trying to clean up the system, well, we can delete that too. So it's not enough to go inside of Procmon and then just delete the registry entry. We also have to actually go to where the file was. Yeah. Mahad FFO. Yeah, pop that inside Discord. Help you out over there. Get out of the stream. Same thing. So who's your daddy? Like, if you, I love those questions. Go and drop those inside of Discord while we continue with the content for now. Don't want to get too off track, but just drop them inside of our Discord. And all 4 tabletop scenarios. It's fun. I think it'll help the community too. So Jordan, bit of recap. So what happened was we ran a neutered malware called the AutoRunner. Okay, so the AutoRunner. So the AutoRunner, that means it's a coffee sip. 1 second. Too much talking previously. And some water sip. Okay. So we ran the AutoRunner. And this is a neutered piece of malware. It's defanged. Nothing bad is going to happen to you. And what we've left inside of it was a couple things. As we ran it, you actually see a nothing to see here pop up that occurred. And you see can't catch the AutoRunner, not you or anyone. No one can. So we actually had 2 statements that occurred. So we actually had 2 pop-ups. On CMD. So 2 CMDs were ran. And so this terminated itself after. Stayed open. So we kind of missed that entry at first. So afterwards, what we did was we ran AutoRuns. And all we did was fire it up. And we saw that there was a registry entry for the current user on the run key, not the run once, but the run key for the AutoRunner was here entry that appeared, which pointed to a roll.bat file. So that was the batch script. So we jumped to the entry itself to see if anything else was inside of the run key for the current user. Looks like it wasn't. So what we did is we jumped to the actual image. So the image refers to, in this case, like the file could be an executable DLL script, etc. And then what we did is we hopped on PowerShell. We didn't want to run that. We just typed the input. So whatever the PowerShell script actually contained, we saw this. And it looks like all what it was a start Microsoft Edge. So it pulled up the Edge browser and it navigated to this YouTube page, which I know, and we're safe enough to be able to run that, which was the RickRoll video. But to be extra safe and secure, we said, okay, say it's not a YouTube link. Well, in this case, what you want to do is actually take this link, because we know that this doesn't do anything else. Like, that's not mysterious. We know it's just going to start Microsoft Edge. So let's take the link and see what it actually does and run it through a sandbox environment, which we can see over here upon loading it. It looks like it just loaded up the Rick Astley RickRoll video. And that's all that happened. That's all that YouTube link actually performed. We also ran the roll.bat script just to be sure through VirusTotal to look for any other malicious entries and kind of go from there. And that's effectively enough to triage it at the AutoRuns level. Now, what we could do, of course, is we can inspect that further. And that's going to be a bit of a challenge I want to put to all of you guys later on. So we're going to do one tool at a time. But what I want you to be able to do later on and hop inside of our Discord is run this roll.bat. Sorry, not run the roll.bat, but run the AutoRunner. Okay. Run this binary with proc XP running and procmon and see what else it does. So I'll leave that open to you to do some more forensic analysis on it, to see like what else did it actually do. Maybe even open up TCPView. Did it do anything else? Did it beacon out on any traffic? So next steps, next first steps. Run the AutoRunner through the AutoRunner. And TCPView for network activity. So that'll be my challenge to everyone else. You can hop inside Discord and see what you come up with. But that's what I'd like for you to be able to do for the next steps on this challenge over here. This little piece of malware. Was that a good recap though, Jordan? Did that make sense? Oh, sorry. And the other thing was I copied the share link of this Any.run. So any of you that have an Any.run account can now go and review what I did. Yeah, glad that helped, Jordan. Good stuff, man. Cool. Cool. There you go. That was your first malware, everyone. Your first, if this was your first time, you have now triaged your first malware. And you performed a little bit of a forensic analysis on what actually happened. Not that bad, right? I hope that builds some confidence. Like, it's not that bad, right? Like, there's only so much you can look at this level, of course. Much more advanced later, you can get into, like, debugging and deep-level forensics and such, sure. But at this level, you have effectively removed the persistence mechanism. That's what you've done. You have eliminated the persistence mechanism so that this malware won't come back. Pretty cool. Now, you don't know if it did something in runtime, like if it, that's why I gave you those steps. Like, did it beacon out? I don't know. Spartacus, this is a template. We're building it now. So the first step, step 1, persistence. That's what we're doing. The first step is we're looking at persistence. Now, the next lab, we are going to be looking at... So that was step 1 in the analyst triad. So if you look at the bottom of the stream, it says persistence process networking. Step 1 is complete. Now we know what to do running AutoRuns, and we're exposed to this level of analyst triage. Next. Let's move on to the next lab. So this is process me if you can. So this is going to be another binary. Hop inside here. And we're going to run the process me if you can binary. Karina, it was a persistence because it started at logon. It was persistence because it had the ability to come back after reboot or after power on and off. That's why it was a persistence mechanism. Not necessarily that I started a logon, because it could have been a scheduled task. It could have been a service. It could have been anything else. Persistence just means that when you reboot, when you power on and off, when you log in and out, it will come back at some point regardless. Yeah. Cool. Seriously, I know this is like beginner entry level in our opinion, but this is still hard. Like, just being able to do what we did right now, I'm telling you, like, I've worked with analysts, and I know analysts in the field that don't know how to do that. And they just kind of look at, like, alerts that pop up, and they just look at, like, an IP address or a domain, and they're like, oh, okay, that's not normal. But they actually don't know how to do, like, this level of triage even. But it's important that you do. Incredibly important. So, step 1. We run something malicious. We're going to fire up AutoRuns, and we're going to look for any type of entry that appeared that wasn't there before and is flagged. Cool. Next step. I'm going to close all this stuff. So I'm going to save that. This is documents. I'm going to save this to step 1, or rather the AutoRunner triage. Close that up. Close this. Let's go and bring our state back to what it was before. Cool. Okay. Next binary. Let's go and work with process me if you can. So the goal of this lab is really to gain a practical experience using procxp and procmon. So that's what we want to do here, is we want to actually put both of them together now and expose you to things at the process level to see what actually could have happened. Oh yeah, so there's actually a step over here, just so we are clear on that. So I actually did want you to set this up. I don't remember why I did that, so I'm just going to do that anyways. So we're going to actually go and open up Process Explorer first before running this. And what was I actually doing over here? Okay, so why was I doing that? I'm trying to remember. I can't remember. So what we wanted to do was just have the same reflection on the lab. I think it was just for like verbosity to kind of capture everything. Or is this just the default? So description, company name, verified signer, image type, yeah, that's normal. Auto start, VirusTotal, depth status, yeah, integrity. Okay, so it's just default. I don't know why. I think I put that, trying to see why I put that there in the lab. Wrote that back last summer. Maybe it was just like a safety check. So I think maybe I just put this over here to go and make sure that if you change your columns around, just make sure that they're set to this so you get the full lab experience, just in case you go off the rails and like you're missing something. I'm going to assume that's why I did that, because I don't have a better answer. Okay, so we have Process Explorer running, and we want to also make sure that we have the VirusTotal signatures are checked. So we're going to do that. Check virustotal.com. Cool. Okay, I think that's it. So that's the startup. We have VirusTotal enabled as a check when processes start, and then we're actually going to fire up the process me if you can binary. So let's fire it up. So here's an interesting malware. We have something that's running, and it's actually saying tick, tock, tick, tock, tick. So it looks like we set ourselves the bomb. Good old reference for you in the crowd. So this isn't good. So this could be an example of some type of, we've neutered it, of course, but this is some type of malware where you've opened up something and something is running and you don't know what the hell's happening. Now this doesn't look good, right? Because it's saying tick tock, tick tock, tick tock. That looks like a clock, like something is ticking. What do we do? What do we do? Shit. NFLD Brad, thanks for the follow. What do we do? Oh no. Pull the plug? Reboot? Turn it off? Let me tell you something. I can't tell you. Math Dragon, thanks for the follow as well too. I am telling you, right? Like, I've lost track of the amount of users that have like downloaded something or ran something, and they're just like, and they freaked out and they just rebooted. Right? Like, they just like, first thing they did, close everything and reboot. I've lost track of how many times that's happened. So based on the last malware that we saw, remember when we ran the binary, what did it do? It created a startup entry under the current user. So if we did that, if that's what a user did, then damn. Well, then it's going to start up a process that when the next time that user reboots, right? So no, we do not want to reboot the computer. Just to be aware of this. WC Dozer, thanks for the follows. All y'all. So what else do y'all say? Pull the plug, unplug it from the network. Yep, so you have to isolate it first, stop from escalating. Disconnect from network first. Yeah. It would be nice if we could, but we can't because we're on a remote connection, right? So buy another computer. Send the file to your CEO to clarify with him. Oh, Jordan's evil. Jordan is evil. Okay, R double. Oh yeah, Doug. Haha. Sometimes that actually works. I know someone physically went to the server and unplugged it, and they accidentally killed an active tunnel. Yeah, yeah. Sometimes it works, but maybe you don't want to unplug it right away, right? Maybe you want a full capture of the event. So we've got Process Explorer up and running over here. Let's go ahead and a couple things we can do. So before we actually take a look at the process, let's fire up a PowerShell window over here. And before we begin, what I want to do is I actually want to run a strings command on this binary. And I'm just going to say process me strings.txt. I just want to do a quick dump of that. Just so that I have it there for reference. And see exactly what it's actually doing. So imagine we had this like capture that happened right then and there. So first things first right away. So this program cannot be run in DOS mode. Yeah, makes sense, right? So that's like that MZ header that we would have seen. If we wanted, we can sort of like look through this. But this is more of just like an immediate forensic capture. Just so that we have something as it happened. Because I don't know what could happen as I start doing things. So the first thing I've done is I've just tried to capture some runtime state information of the process before I begin interacting with it. So that being said, I'm actually going to kill that off now. I don't want that getting in the way of what's actually happening over here. And I know that I have Notepad open just because. So, cool. So let's go ahead. Process me if you can.exe is running. It's also got a connection host going on as well too. Let's take a look at the threads. So threads are kind of just not really doing much. User request, executive. So nothing's really moving other than the TikTok that we're actually seeing, right? So it's this right here. There's an active connection to something doing anything. Let's take a look at the DLLs. So this is immediately flagged right away. So these are all normal Windows System 32 DLLs, like that's normal. Yeah, Chaos, you could pause it. If I could pause Process Explorer right now, or I could just even suspend this, but I don't want to just yet. What else are we seeing over here? So we've got 6 out of 79 on VirusTotal. That's pretty bad. Just going to click that link, take a look. Real quick on that. So we've got some adware. Google's detected it's a Trojan. Shellcode runner. Static, yeah, suspicious, portable, executable. It's a couple different things. Some hashes provided to us. Import some kernel 32. So what's it doing? Create file, create thread. And exiting. Close handle. Okay. Wonder if anyone's actually submitted this before. Contacted IP addresses. Behavior. Okay. So some people have ran some things. Execution. So a lot of people have actually linked some intelligence already on this. Interesting. Cool. Okay. But nothing on the community. Okay, so some initial checks based on what these detection tools have been able to run against it have provided some general intelligence on what to do based on VirusTotal. There's some type of threat operation activity happening over here. There's a crate file open, and then there are some threads that are just executing this TikTok over and over and over again. Okay. Just going to move that aside. Where's my window? Let's take a look at TCP IP activity. Anything going on inside of there? Okay, interesting. Let's take a look at the performance graph. So take a look at this. So it looks like when I'm active in the window, take a look at that. It's actually, there's disk IO activity. Oh, my shoulder. Why was I sitting like that? Okay. So when I'm active in the window, and when I come out of the window, it stops. Interesting, right? So let's go take a look at Procmon and see what the hell is actually going on. Let's reset this. Let's go to process.name is equal to process me if you can.exe. Right? That's what it was. Add, apply. Oh, wait, there was something there for a moment. There we go. Okay, so what's it doing? What is it doing? Well, it looks like it's actually doing something anyways. Now, for whatever reason, it looks like the process seems to like stop a little bit when I'm in and out of Process Explorer. But it looks like that doesn't matter. So what are we seeing here? Create file, close file. Write file. So it's actually doing something under C users administrator. I have been process.txt. Now what's interesting is, so it looks like it's fired back up. So I don't know what that is, but there was some chain of events and now it's just running on its own. So don't know. We don't know what's going on there. Now that could just be like a VM issue. That could be like a timed out on the VM connection or something. That's possible too. But what we do know is that this binary when executed didn't look immediately like there's nothing wrong about what it's doing. It's just saying TikTok, and there's no TCP IP activity, but looking under the performance graph was able to provide us an indication of what's going on with the system IO. And we could see some read and write events that are happening inside there. Now, the threads themselves, let's take a look at that. They're kind of just doing their thing. They're just like executing. Now, what was interesting is opening this up inside of Procmon gave us a much better image of what's actually happening. And it looks like there's a thread that is executing and starting every now and then, and it's writing to I have been process.txt. So is it writing this file in the command line, but on the command line when you're interacting with it? It looks like it's doing it regardless. Right? So read file length, read file length. So let's go and take a look and see what exactly is this. Like what is this? Okay. Let's see if anything else is inside that folder. So there's the roll. We should delete that. That's from the previous one. So I'll close that. Oh, shit. Wait a minute. Okay, well, wait. No, hold on a second. So take a look at this. Let's go back to the Procmon, right? So it's writing to the file, but it's also deleting it. Damn. Let's take a look at this. Like, we can see it happening in real time. Okay, so if that's the case, let's go and keep this here. And I'm just going to wait. And the next time it pops up, I'm going to suspend it. Okay, let's suspend. Yeah, can you suspend it? Nice, good thinking, guys. Okay, let's open up PowerShell window. So it looks like a text file, but is it? You found me after all. You're getting better with Scissor Turtles. Well, that's a friendly threat actor, isn't it? Isn't that a friendly threat actor? So, okay, so that's interesting. Now, let's go back to the process itself. Take a look at the strings. And this is the same thing like the strings dump that we had before, but I actually want to search for that. I have been processed. Oh, lowercase h, right? Yeah. Down. Let's copy this and see if it's actually inside here. Or am I just typing something weird? Okay, it's not coming up in the strings. It's probably because I have it actually, I don't know. Let's take a look inside the initial string dump. Okay, yeah, here we go. So it's actually inside here. Wraparound. So what's happening inside here? There's a read. Find next. Okay, so there's only one reference of it. Already exists. File does not exist. Already closed. Destroy. Okay. So it's looking for the file. If it's there, it deletes it. And if it's not, it creates it and it puts an entry for us. So this is actually reflective of, like, this is like what beaconing activity is like. You see, like, there's an initial track that's been covered up over here, right? But when we're able to suspend the process, we could see what actually happened. Very cool. Very cool. So let's go ahead and we can resume that. And let's go back to AutoRuns just to be sure. Just let that run for a moment. Karina says, so was it safe to cat type I've been processed outside of Sandbox? Yeah, totally. It's just putting the output to the terminal. The terminal won't execute it. It's just taking standard out, right? When we do the cat or type, it's taking standard out and dumping it to terminal, but not to be executed. Yeah. It's not an interactive environment. Now, if we just ran the file or put the file through another shell, which has execution permissions, then yeah, that'd be bad. So yeah, that was the original auto run, so the file was not found. We can get rid of that entry now, actually, from the previous time. Yeah, cool. Doug's saying, I think everyone is enjoying these malware dive analysis. Yeah, and it's fun, isn't it? Yeah, so interesting. So what happened, right? Let's, okay. So process me if you can. Okay, so what happened? Ran the process, ran the binary for inspection, started up a terminal that CMD that kept writing tick and talk on new lines. Let's do format that. That's kind of bothering me. Cool. Inspected threads, DLLs, operations, and found nothing other than disk IO activity. No TCP activity. So there's no networking. Well, later on we checked AutoRuns, so I'm just going to say, to remind myself, remind self, checked AutoRuns, no persistence. Okay. Next, we ran procmon filtering for process.name is equal to process me if you can.exe. Observed file create, write, close on users administrator I have been processed.txt. And then what was the output? Let's just do that. Copy this. Okay, so pretty cool. So let's say this sample output capture of contents. Okay. So now we have a sample that we were able to capture over there. But super cool. So inside the file, it looks like the threat actor let us a nice little thankful message. They're testing our skills, but there were procmon events that were able to lead us to see what's actually happening with the process that wasn't visible with Process Explorer. And that's really what I was trying to say is like the importance and the power of working with threat operations is this is, I freaking love procmon. Like it is going to tell you what's happening. You're not getting around it. So when you're doing some level of defer, having a tool like this or the ability to pipe threat operations out for analysis somewhere else or to capture it for analysis or forensics later, etc., is so important and valuable because we would have missed this if we were just looking at auto-run entries and persistence and just inspecting the process. We would have never known that this was happening. Now, this is a neutered piece of malware where it's just writing to a file somewhere, but what if this was something else? What if this was capturing information ready for a beacon? Or what if this was actually just beaconing activity that was sending out like raw TCP or UDP activity as actual events? We wouldn't have seen that. You wouldn't have seen that at the process level other than some type of activity happening from like the disk or TCP activity. Exactly. Doug was saying, like, how do we know that this is not a keylogger? It has properties of one. This is very much like a keylogger activity. Now, if you had a keylogger, you would see a whole bunch of like key capture events that are happening here and writing to a file as well. So super cool. So at this point in time, now if we terminate this process, I think we've been able to figure out everything that the binary is capable of. I'm going to go ahead and I'm going to close this session. So that closed up. And we're still capturing it. So thread exit. So process exit. So as we exited the process, what happened? These are normal local machine services. Like these are not auto-run entries. And it closed the file as well. Well, I mean, sorry, of itself. And then it closed any registry keys that it had open just for querying. So as we close the process, nothing else happened after with the process name itself. So interesting. Very, very interesting. Now, if we wanted to be super sure, which I can lead over to you, is maybe we could have left procmon open filtering for additional events that happen after this. Terminated process and file writing closed. No further activity indicated. Just to be sure, for good measure, open up TCPView. Looks like normal service host processes were firing the same. There's no like random rogue process that's kicking around, and that's just Edge over here from before, which we can close up. Cool. Very cool. You see? Hopefully your confidence levels are going to start increasing a little bit more now, knowing that you can just use a tool like this, right? So now we've done the second step. So we've looked at persistence. Now we've looked at process of how malware can behave. And we've been able to demonstrate that with AutoRuns, we're able to look for entries that could be related to it. And Karina's saying, I was wondering why VirusTotal flag process, even though it was defanged, the hash wouldn't match a bad version. Well, this is why. You see those procmon events? These procmon events are indicative of something suspicious. A normal binary, something trusted, shouldn't be opening up and writing and closing a file every, what, second? Looks like? No, faster than that. It's every few seconds, actually. Every 3 seconds. Every 3 seconds, the binary was writing to a file. So, yes, like it was defanged, but that's a malicious pattern. That's what we call TTPs that we're going to be looking at in cyber threat intelligence. Is patterns of activity can still be indicative of something malicious, even if the result is not a malicious output at the end of it. And that's why this got flagged. Cool. Yeah, that's why exactly Doug's saying, yeah. Yeah, it's not just about the output, but the pattern. So this is like what, so like Doug's all about this, right? Like when he's performing threat hunting, this is what he's doing. Like he's looking for patterns in activity. So now you know under the hood what's actually happening. And you're now ahead of, like I said, of SOC analysts that are out there in the field that are just waiting for the alert to tell them what happened. You now know actually how to get underneath it and run tools like this to perform your own level of light defer. Like this is like tier 1 to 2 type of defer. Cool. And I'm telling you, if you can go to an interview and walk them through even these 2 labs, I'm telling you, you are going to very much impress the recruiter if you're applying for like a tier 1 type of position and you can talk about this kind of stuff. So, Doug, you're thinking like a bad guy. Yeah, basically it's every day, but more advanced and different ones every day. Yeah. But effectively, it's, you know, like what Doug is looking for and all of us is like, the thread operations is the real meat and potatoes here. Like this is what you could really, really see. KSJ, so do you think we could make this a project or something similar? Yeah, totally. So yeah, we are going to be making a student community GitHub with the career prep stuff inside that people have been sharing, but we're also going to have a career community, we're also going to have a community GitHub where you can go and like provide defer write-ups and explain what you've done, and then you can contribute it and have like a little community area, and then you can put that on your resume and be like, hey, like take a look at like my write-ups, or if you want to host your own GitHub, you can do the same thing there too. Either one's fine. But this is totally a project you could do and host online in a blog, a GitHub, or a shared community space like the one we're going to fire up. And it's not so much about you just being like, oh, I can use a tool, I can run a filter. That's not important. What's important is the ability to walk through a narrative of why you took the steps that you took, what evidence led you to what, and why did you do those. Like there was a clear reason, right? So we dumped the strings of the binary prior to so that we would have a proper capture. and then we ran it, we didn't get any activity that could indicate to us of something clearly malicious inside of procxp, other than we had disk IO activity happening, which was strange. So to get more under the hood, we pulled up procmon, which gave us a raw view of the thread operations of what that process was actually doing with events. And that's how we saw the image path of the text file that it was writing to. KS saying, you know what would be awesome? A full course bundle of pre-configured labs and challenges for practicing. The more we put in the practice, guess what, KS? That's what's coming next. So that defer course that we're building is going to be that. It's just like a whole ton of experience. Jordan's saying learning to do things the hard way first is better than learning. Yeah, totally. This is why we're not like, hey guys, here's like Sentinel and a bunch of alerts for you to look at, and then like, oh, like this is, look out for this IP. No. We want you to get your hands dirty. Yeah. And then you can use the automated tools. Yeah, KS. It's good validating feedback for you to say something like that, because that's exactly what we're building. So it's good to know we're on track. Appreciate it. First things first is we got to get through the SOC100 content and give you a foundation. Something you can always refer back to. Yep. You can use threat intelligence area free. Yeah. Search for attacks or instances of DLL attack. Yeah, exactly. Cool. Okay. Let's take a little fiver, and then I think we're going to do the last lab. That's good. Abe, do students practice honeypots, honey tokens, decoy networks? Not in SOC100, no. Not in CDA either, because that's just more advanced skill set to develop. But our threat hunting stuff. So yeah, like that's kind of where Doug is going. We're gonna be getting to like more threat hunting, adversary emulation and simulation types of activity like that. Yeah, I think it would have served me better. 100% R double. Yeah. Easy wins for companies reach you. It's true, man. Xeno, so at what point do you perform a static analysis? I mean, like after this. Yeah. That's where we get into CDA. CDA is where we actually start doing static analysis. SOC100 is enough for you to develop a tier 1 triage skill set to say, okay, like something is wrong here, escalate. Because like that's what your tier 1 analysts are doing. Like they're just like, yep, false positive, true positive, false negative, etc. And then like, okay, like yeah, and sure, like you might have some skill to be able to do it, but that's where you would get into like that tier 2-ish kind of level and up, and that's what CDA starts to teach you. CDA is where you start to perform like static analysis and get deeper under the hood. And up. Yep. So advanced courses are after we start. I mean, you could get a job like right now. So CI, like look, we've like Bearden and Ariel, right? Like they're starting. I told you guys before, like SOC100-1, it's enough to go get you entry-level IT work. Like, go and apply. If you can get through SOC100-1, there is no reason why you can't do help desk analyst work. And if you can get through SOC100-2, there's no reason why you shouldn't be already applying to like really entry-level, like SOC Tier 1 type of associate analyst positions. No reason why you shouldn't be doing that. CDA is just going to make you a better analyst, and then our detection engineering and defer content is just going to make you a better detection engineer and a better digital forensics and incident response analyst. That's it. Yeah, Ave. Yeah, sounds good. Karina, awesome. It'd be difficult if it overlapped with March CDA Live. Yeah, I mean, create a, don't worry. Like it's you'll be good. You'll be good to get in CDA live. We're not trying to trick you. Like if you can just get through the content, you'll be good. The defer content is in production. I would expect it over the next like several months. It should be coming out at least yeah, soon. soon. To start CDA, you just need to be able to pass the 4 assessments. SOC100-1, 2, 3, and 4. That's it. Pre-order? Yeah. Well, look out for some news. We're going to be having some things coming out soon on that. But yeah, there's going to be some like... we might do a beta test. We'll see. But anyways, let's take a break. And when we come back, we're going to take a look at the last piece of malware activity of the triad, the analyst triad, and that's network activity. So we want to see what we can do after we execute malware and it's not giving us AutoRun or like persistence or process related information enough for us to figure out what's happened. Well, now we need to move to network. And we've taught you this in this order because the persistence is probably your easiest thing to find. Process, probably your second easiest, and then networking would be the hardest of the 3. Because remember, networking is going to be the final piece of the puzzle where the malware wants to get in and out and do its order of operations for its complete action and objectives. So it's going to do its best to hide over there, and it has a lot more of an area to hide within protocols and hide in other things. Persistence is pretty straightforward. There's only so many auto-run locations. And process, as you can see, if you're not sure what's happening with the process, pull it up in Procmon, and you can get a pretty clear view of what's happening there too. So let's take a break. What's the last thing over there, Doug? Anthony, I've been teaching you stuff that is advanced. Yeah, like I'm. That's why I said that. Yeah, I appreciate the backup there, Doug. Yeah, I'm serious. Like if you can just even talk through these 2 labs, you're going to impress recruiters for tier 1 security analyst positions. Doug's not kidding. I'm not kidding. We're not blowing smoke. This is hard for a reason, and this is why like you guys are like, oh, like I'm getting through, but it's still hard. Yeah, because this is hard. This is advanced stuff. But we consider that entry level because truly that is what entry level should be. So we train you for that so that you're the best of the best. Is tier 1 positions that basic? Yes. A tier 1 security analyst is that basic. Yes. It's perceived to be so much harder, but it's not. It's just your ability to work through identifying IOCs like we've been covering. We're going to do that even more with like email security and whatnot after. Anyways, break time. We'll be back. I need to set up my camera in the beer back button on the stream deck. Okay, bear back. Cool. Okay. Much better. Got the buttons programmed on the Steam Deck now, so I can kind of flip them off and on, looking away. Don't have to mess around with the OBS. Sweet. KS, some chat while I was gone. It's really hard to break. Yeah, it is harder to break into the industry, especially now. And then, yeah, having this type of experience that you can demonstrate and walk through is really going to push you ahead of the competition. Now, I always advocate there is nothing wrong with like starting as like an IT analyst. I think that's great. I think you're gonna learn a ton. There is nothing wrong with that. Now, if your heart is set on starting as a security analyst as the first job, that's fine too. Just make sure you can show you can do the work. And this is where you have training like this to do, and then you can build a portfolio to communicate that because you don't have the experience. So if you don't have the experience, you need to show it a different way. And that's what a portfolio comes into work to prove you can do it. Yeah, you've heard horror stories, Jordan. Yeah, definitely. Karina... Yeah, so KS saying it makes you stand out from Sec Plus. So everything we're doing, a Sec Plus doesn't test you on. Forgot to put myself back in the cam. Stream tech. Okay. Now I'm back. Anyways. Anything that is on the Sec Plus doesn't test you how to do this, what we've done. It tests you how to generally talk about like that these tools might exist. That's the clear delineation between what a Sec Plus does and tests you for versus what practical training does. Gotta sneeze. Whoa. Big sneeze. Sorry about that. Karina, hey Anthony, before the break, you mentioned passing, yes, to get a CD Live. Yeah, those certification tests. So if you go to like leveleffect.com and you go to certifications, as we're releasing these SOC 100 certs, you must complete 100-1, 2, 3, and 4 before you start CDA. That's it. That's it. That's it. That's all. The ghost of Anthony, yeah. The ghost of Defer passed. Pandem. Sec Plus is theory, yeah, exactly. KS, not even some of your university classes. True. Yeah. It's just how it is. Okay, cool. Final lab. Final lab. Let's do this. Windows Triage module. Let's get into the lab. Nettin' but time. I love these lab names. They're so corny. So good. So Nettin' but time. Let's go and figure out. I wonder what that could mean, right? What does that mean? Okay. So back in our Windows workstation. Let's close, save this up. Process me if you can. And also, while I'm doing this too, like when I say things like this is the clear delineation between a Sec Plus and practical training, don't think for a moment that I'm saying the Sec Plus is not valuable. It is. Just like practical training is valuable. Theoretical training is also valuable. Because if you can speak and understand the terms and definitions of everything that you're looking at, it will expedite the knowledge transfer of understanding the practical task at hand and immediately being able to work with it, as opposed to having to stop continuously, being unable to visually understand in your head what these things actually mean. So if you're trying to do a lab and you keep getting stuck on things like, if you see like TID and you don't know that stands for threat ID, that's like a moment of friction. It's a bump. I like to look at theoretical knowledge of the less you have of it, the more speed bumps you're going to have in your practical training. It's just going to be constant, like slowing you down along the way. So if your theoretical training is good and you generally understand things, then it's like getting on the highway. Does that make sense? So there is a valuable purpose for it. DevOps 4577. You're still learning how everything works, but just want to say how valuable this course is. Thanks, man. The knowledge materials and the price are unmatched compared to the fake cybersecurity courses out there charged so much for little. It is unfortunate. There are quite a lot of very, very bloated in cost cybersecurity training content that is not much to it. That's just the reality. It's unfortunate. I think we should put this course out there so many people can benefit from the real quality training like this. Thank you. Yeah. Honestly, if you want to get... That's the thing we always ask for. Like, if you want to support us, Level Effect, spread the word. Tell people, hop on Reddit, hop on LinkedIn, share what you're doing and why it's of value and what you learned. And that's all we ask for. Truly. That's it. I think the quality should speak for itself, and I really appreciate that. We all appreciate that, so that we can continue doing this, because then we can see you grow. And that's what we want to be able to do. It's an awesome thing for us to hear, like, you guys got a job, or you wrote a lab, or you wrote a project, or like things are clicking now and you're like, oh, this makes sense. That's it. The more we hear of that, the better. Karina, I totally agree about explanation. Yeah. About theory. ... Another question coming. Jordan. Cool. Thanks for the recommendation. Thanks, guys. The support definitely helps. So thanks for being here. Cool. Okay, last bit of the lab. Let's minimize these things. We're going to reset our environment. Go back inside of all this stuff. Let's start from the beginning, okay? Last piece. Netting but time. Netting but time.txt. Okay. So what we're going to do, we're going to go inside here, and we're going to go to our Foundations lab data. We're going to go to Windows Triage and Malware Analysis. And we're going to run our final binary, netting but time. Now, before we do that, first step, whenever you're going to be running binaries from now on, you're going to open up procxp. You're going to open up AutoRuns. And now you have a snapshot of AutoRuns. Let it complete. Let it take a full snapshot. Okay, we're going to minimize that. Now this is good to go. Like, let it do its thing. Okay, this is done. procxp, this is now running, so we can get a full idea about what's happening. We know we have a couple notepads open, so this is like our baseline. Okay. Next thing, let's go run it. Before we do, there's no arrogance in teaching, as many out there. Try not to. I'm just trying to deliver the news. Jordan, greed, very little ego. Yeah. There's no real ego in our community, and we stamp that out real quick as well too. It's one of our Discord rules for that reason. Like, there's no farming allowed, you know, like we don't want people coming inside there and hopping in conversations, trying to like take it over and showboating, you know, like breaking up things and kind of like it's all about them. It's that's one thing that we definitely don't like having around. So just be cool, chill, calm, normal, kind, help one another out. That's it. And no one knows everything. I don't know everything. So just go into it with that attitude that you're ready to learn, you're ready to share what you know, and be open to not knowing. Be open to being wrong. And if you feel you're right, explain why. That's it. It doesn't get more complicated than that, right? People forget. People don't know what they don't know. Yeah, exactly. I've seen too many people in Discord be letting someone happens, man. Okay. So, let's go and fire up net and butt time. Interesting. Okay, so now we have a piece of malware. This has been neutered for you. That there is no visual cue. I don't see a TikTok. I don't see, which I think TikTok's banned today, right? I don't see like a command line saying TikTok, TikTok. I don't see things popping up. I don't see any of that. So now you're dealing with some malware that is just showing you a blank terminal, or maybe even nothing. Ariel, you think it's back? Yeah? You think TikTok is back already? Oh, okay. I don't know. I haven't been following. I just kind of heard that it was banned today, and I saw screenshots, but they could have been fake. Okay, so what do? Right? What is the next step? We ran some malware. We don't know what's happening on our system. Well, AutoRuns. Did anything change? Let's go inside of here. Let's refresh. Check out our logon script. CMD, nothing inside there. Scheduled tasks. Nothing. Services look the same. Cool. So, let's find out what's going on. Nothing. So, persistence mechanism is not visible this time. Blank terminal. CMD appears after execution. It's back. DDoS. What platform are you using? Like for the stream? So this is it Windows, man. Yeah. Yeah. We're using CourseStack. So CourseStack.com is the course. Learning, like the LMS. Amazing platform, by the way. Whoops. CMD. Thanks, Tom. Blank terminal CMD appears after execution. Okay. Level effect course. How much cost? I definitely need to get that little explanation thing to come up that can help. So we're doing the SOC100 courses. They're minimum pay what you can, $19. Recommended $29. Pay what you can. Or if you are not financially able, hop on stream with us. We're going through the content. You can catch up on all of our YouTube recordings, and then you can just do the home labs yourself. So trying to help out everyone. Okay, so nothing appeared. We have a blank CMD session. Now, let's take a look. Cool. So what do we see over here? Net and butt time. Let's take a look. Process. Threads over here. In the queue, user request. Cool. DLLs. Let's take a look. As expected, system 32. It looks like it got flagged right away, but we're calling DLLs from the system 32 location, so that's normal. So there's nothing sticking out, like there's no DLL located in the home directory or somewhere else. Okay. Let's take a look at net and butt time. Process itself. Do a quick scan, skim through the strings. And all what I'm looking out for here Program files go. Okay. Go string, go binary. Cool. Okay, let's take a look at the performance graph. Jordan might have already answered the question. How do you gather a baseline and everything? The baseline is just going to be your environment's trusted state. What that means is what is your normal level of activity? And then you record that as your base state. So example, AutoRuns, I ran it first. That was my baseline state. I then executed the binary. I refreshed it. And then I saw that there were no changes. So I could say my baseline didn't change. Now, over time and exposure, you will start to gain an experienced eye into what is going on with all of these adjacent associated files. To that end, there is no analyst or human out there that can just kind of look at a screen like this and be like, yes, I know exactly what every single one of these things mean. If you can find someone that can walk me through and explain every single thing on any workstation that they hop onto by pulling up AutoRuns, and every process, every thread, every technical term, every operation like that, well, then you found like the next evolution of the human race. And that person should be like that's the next human. I mean, I don't know what to tell you. It's not happening. So first of all, don't put too much pressure on yourself. Secondly, you will start to learn how to rely on visual indicators. So we have given you a trusted baseline for this Windows workstation that we've taken time to analyze. So your job in this case would be to review the previous snapshot of AutoRuns and then what happens after you execute something. That's the baseline that you need to be aware of. And this is why we use these types of forensic tools, because the baseline here was the process was not running. It's now changed that the process is running, and now we just need to inspect what it's doing. Don't go in a rabbit hole. Just stay focused on what the evidence is telling you. So in this case, the evidence is telling us at this time that there are read-write operations that are happening, and there's some committed memory to this process. We also know by looking over here, take a look, it looks like there is actually TCP/IP activity happening to 10.0.0.71 on port 9001. So it's over 9,000. That's not good. Because it's over 9,000. So that is never going to get old with me. Okay. So what else do we know at this point in time? Let's write it out. Indication of disk I/O activity. Every what? Let's see. This is like 609, 610. What is this? Every minute? Or every 30 seconds, maybe? 908, 920. I don't know. It looks like every 30-ish seconds at this point in time. Approximately every 30 seconds. Let the evidence... Every 20 seconds? Thanks, Ariel. Every 20 seconds. Let the evidence guide you. Okay? So what else is going on? TCP activity 2. 10.0.0.71. Port 9001. At this point in time. Can we ping that? No activity of that. Can we ns lookup? Okay. Can we? Is curl actually on the system? I think it is, right? Okay, curl. HTTP 10.0.0.71 9001. Leave that going. Maybe it's hung up. Okay, so nothing's happening. Okay. Private IP. Cool. Let's hop back inside the process. Let's take a look at strings. Can we find anything inside here? Okay, so we did a search for the IP address. Reg open key. Get host by name, get server by name too long. So there's something inside here. Let's open up PowerShell. Let's do a search inside here. Okay, here we go. Excuse me. Yeah, so I mean, so like for example, like I'm looking at this right now. I mean, I don't understand half the things that I'm seeing right now, but what I am seeing is that there is something here that is trying to say get host by name. So there's something going on, at least at the code level. (9001). Okay. So not entirely sure what's going on. Let's take a look at the... So disk IO, read bytes, 73 reads. No network IO. Now, this makes sense, right? So there's no network IO because we can't reach the host. Function in strings indicates to get host by domain, or rather by name. Inspecting disk IO and network IO reveals there are no transferred bytes between this host and ours. Therefore, if this was trying anything obfuscated or encrypted or something, or trying to hide between protocols, it doesn't matter because there's no network connection happening. If there was a network connection, we would have seen some bytes being exchanged. So we can say at this point in time, like, the malware is completely neutered, like it's not firing. Okay. So that's how we're just kind of like validating this stuff at this point in time. So what do we want to do? Procmon, right? Like, what are the process events that are actually happening now? Procmon, let's reset all this. And let's think about this. We are looking for, first, a stretch. So we're looking for, to fix that shoulder reach around, because I have my iPad. 1 second. Let me move the iPad. So let's think about this. Oh, much better. if we have TCP activity and we don't have a connected host between us and the target IP address, and we've been able to validate that there is some form of disk IO activity happening and attempted network connections, well, we already know, right, that it's dialing out to 10.0.0.71.9001. So something's going on. Karina, you appreciate how you're taking notes to show your analysis process? Yeah, for sure. Trying to help you build out like the methodology, like why are we doing what we're doing? Okay, so inspect procmon related TCP events on netn, but time to figure out what is going on. So let's fire it up. Procmon, let's reset everything. And what we want to do is, so we want operations is TCP. So we got a bunch. Let's just throw them all on there. So connect, disconnect, other, receive, yeah, okay. Reconnect, retransmit, send, copy, unknown. Okay, cool. Okay, let's see what's going on here. So we have TCP send. So this looks like it's actually dialing out. So what is that, right? So this is the Amazon server dialing out. So there's some type of exchange happening here with a gateway. And this is all service host related, right? Like this is not related to us per se, but it's good to know. So, oh, whoops. So we have a bunch of service host process that's happening. That's normal. Like there's just communication happening with all the Windows services. So we had a disconnect, and I might have to do a little bit more of a filter. Reconnect. And reconnect. So we can go to filter, and this is called netbutTime.exe. Let's also include process, because there's a lot of service host names. netbutTime.exe. Let's get a better idea what's actually happening here. Yeah. Okay. So we've got a bunch of reconnect attempts. Finally, disconnect, because so the session's closed. So it's currently trying to beacon out to 10.0.0.71.9001. Let's take a look at TCPView, just in case we can get any more information what's going on. Let's get rid of IPv6. Do search at top. Just going to type in netn, see if it leads us anywhere. So SYN flags being sent. Let's do view, update speed 1 second. So looks like there's just no further activity that's happening, right? 9001. So it doesn't seem to actually be really going anywhere. Let's pull up. So let's try to get a little bit of an idea what's happening under the hood, because we're missing some information now. What's happening beyond the the request level? Let's reset all of this and go back to just the process.name, netin.time.exe. Let's clear that. Give it a second to load. So there is no other event activity happening with this process. There is, the disk IO is effectively just going to be the initiation of this, like it's trying to perform something. And that's, you get disk activity regardless of that. Okay. So at this point, what do we have over here? Cool. So let's see if we can capture anything inside of Wireshark. Yeah, J Money. So that's exactly what I'm going to try to do now. So it's sending send request, but getting no response exactly. So is the disk activity just socket activity? Yeah. Yeah, effectively at this point in time. Come on, Wireshark, you can do this. You can load. So what I'm trying to do now is, am I actually able to use Wireshark as a sniffing tool to capture anything at the application level? Like, can I capture any of the headers, any of the frames, like that's being packaged up and bundled in this process? Because we're not doing like full static analysis of the binary and like reverse engineering, right? Again, this is like lower orders of tier analyst, like tier 1 to 2 type of analysis to figure out what's going on. I don't want to update that. Okay. So let's see. We have activity going on Ethernet 3, so we're going to capture on this. IP dot address is equal to 10.0.0.71, right? Okay, so let's take a look. TCP flags being set as per normal, so just the SYN flags are being set. Cannot establish connection. Okay. So there is no other activity happening at this point in time. So this is indicative of like a malware that has been neutered, or maybe in the real world where it can no longer connect to its infrastructure. And you might have something running that is just like a ghost process at this point that is just beaconing out but not going anywhere. But we had to rule it out. We had to actually rule it out and be sure and let the evidence guide us. And notice how, like, I don't need to go and read all of these different config files and drivers because that doesn't matter. The evidence at this point is pointing towards what is actually happening. And that's all I need to analyze. So captured Ethernet 3 adapter activity under IP.address equals 0.71 and only caught TCP SYN requests with errored out connections. That's it. That is it. Nothing else is happening. Cool. Now, just for good measure, let's open up the old procmon. And I'm going to go and go back to Process Explorer. So that's running. Cool. Okay. I'm going to terminate that. So that took a little bit to terminate. And the reason why it did is because we had SYN connections being sent out that needed to wrap up. So it wasn't as immediate. So that's normal. Okay, so let's take a look on thread and process exit and see what actually happened now. Okay, yeah, so read the file, that's normal. Threads are being exited. Process is now officially exited at this point in time. And now we just have Windows wrapping up the remaining registry keys that were being queried and read from. And finally, one final TCP disconnect session to the address. So that's it. No persistence, no process-related IOCs on this host anymore. This is just some dead ghost malware that's trying to beacon out to something that our endpoint has no connection to. That's really it. Cool. But see how all the tools kind of came together? We had to kind of layer them all up at this point. We did a full investigation. We looked for persistence in AutoRuns. We looked for process activity that could be indicative of something strange or anomalous. We looked for thread operation activity, and between those two, we're able to determine that there's some disk IO activity happening with the process running, which is normal, but there was nothing being written to disk. There's nothing being captured. And then there is TCP activity that is attempting to connect, like there's initiation, but there's no transference of bytes, and we were able to confirm that with ping, DNS, and Wireshark capture to see what's actually happening on the wire, and it looks like just a dead TCP connection. A SYN request is going out, but nothing further. That's it. Netting but time. This one's a wash. There's nothing to this. We're done with that malware. So we did the final step, working with network-related IOCs in this case. Karina, so when you clean up the malware, I was wondering how can you be sure you got everything? Well, by our investigation. There isn't anything more than this. There are no startup entries. There are no other rogue processes, so when I reboot, nothing will restart. There was nothing written to disk, and there's only SYN requests that are going out, so there's no connected network session. I have nothing to worry about. Yeah. Remember, when Windows is going to reboot, unless there is something inside of the startup entries, or something significantly worse, which is significantly out of scope, that's well beyond, like, this is like super advanced level, and we're getting to like firmware and like hardware level types of threats that are persisting beyond boot. At this point in time, there is nothing indicating that anything will return on when I reboot. Yeah, well, Karina, the internal checklist is the checklist that we're doing right now. Persistence, process, networking. I've ruled out all three. I'm good. Now, if, like, beyond this, and remember, this is like tier 1 analyst, like, we're training you for this. This is why we also have, like, the ability to quarantine this workstation and perform, like, memory forensics and find out if there's truly anything else happening. But that is well out of scope for what you need to know at this level in the game. That is tier 2 plus. That's very advanced stuff. Yeah. You have to remember, like, it isn't the job of every single cybersecurity professional out there to be able to perform a full, complete, thorough, from hardware to software investigation of malware. That's not realistic. If that was the case, we'd have a lot less people in the field, for one, not able to keep up with that expectation, and two, there wouldn't be enough money to pay everyone to be able to have the level of knowledge to perform that level of security analysis and risk confirmation. This is what I mean. Like, don't get ahead of yourselves thinking like, oh my god, like you need to be the master of everything. No. You are tier 1 analysts. You're here as a front line of defense. You're looking for false positives and things. You're triaging things. And if anything further than that happens, well, this is escalation to advanced cybersecurity work. Jordan, is there any case studies with investigation process like this that go through upstream for further reading? Yeah. Go take a look at DEFA report. Here you go. Full summary. This is what we train you for, like in CDA. We train you to this. This is where we're training you to perform full DEFA investigations to that tier like 2-ish level. And then the new content we have coming is to take you even further from there as well too. But you'll find full investigations of this kind of stuff. Yeah. Advanced. But I would bet that if you were able to go and read through some of these reports, I don't think things would be totally beyond you at this point now. Take a look at this. Process create. Here's a threat operation that we've seen before. And we're going to be using ELK to perform what they're doing here, looking at events and logs. Here you go. What's this? Run DL32. We talked about that on the previous stream. What's the target image? lsas.exe. We've talked about shadow copies being deleted in the past as well too. I think you know more than you think at this point in the game. That's what Doug was trying to share with you as well, and that we've been saying. You actually know a lot more than I think you guys realize. But cool. It's another piece of malware down. 133. I think that's a good spot to wrap up, actually. So the rest of the module here now, you've now been shown persistence, process, and networking. Your challenge now is to go and complete these 3 challenges with actually... These are more advanced pieces of malware. These ones will actually function a little bit closer to malware. You're going to have to do some investigation to what these things are actually doing. Okay? So please make sure that you do these challenges. Honestly, like these are mandatory if you're taking the course. They're really going to test you. And then next weekend, we're going to kick into email security. I think we could wrap email like a day. We'll see. And then we're going to kick off log and event analysis as well. Going to get our hands using ELK. So that's a wrap for today, everyone. Karina's saying a couple people, including Jay Monday, mentioned reverse engineering. Is that reversing decompiling from the binary executable? Yeah, pretty much. Yeah. Email security is super important. Yeah, totally. Totally. Cool. Yeah, Jordan, thanks for your time. Yeah, definitely. Glad you guys are enjoying. You'll all be ready soon. Yeah, KS saying emails pretty much. It really is. Like, this is why we have a full module on email. You're going to be dealing with a lot of those. Cool. To be known, first stream here. You're going to try to catch more. Cool. Well, thanks for being here and thanks for staying with us. Glad you enjoyed. We're going to get deeper and deeper now. It's only more and more advanced as we go on at this point. Email's important. Yeah, just got hit by a Russian hacker. Yeah. Yeah. Like, look, you don't need to even be that advanced to improve their overall security when someone just sends an email and the I don't know, like the financial controller opens it up and executes it, and they have local admin privileges, and then their workstation gets compromised. Honestly, all you need to do is do what we did today, and you can find out what happened with it. Truly, you do not need to be a reverse engineer, and it's arguably not even that important at that point in time. Remember, business value, right? Cyber risk. You're not being paid. The CEO is not going to be like, you know what? I want to sit with you for an hour and I want to look through every single piece of code you found and that you reverse engineered and you decompiled. No. They just want to know, is it gone? Is it coming back? How bad was it? Did we lose anything? Okay, cool. Let's go back to business. That's it. Welcome to the realities of working in cybersecurity. Yes, it's great if you can do that stuff, but we're talking about business value. And the business is there to make money. You are there to ensure that it can by not being compromised and get it back into operation as soon as possible. Now, a small selection of businesses out there and the government, yes, they will be paying for analysts that are top tier to perform lots of forensics and reverse engineering at a high level to provide intelligence for the community. But that is a smaller portion of the security work out there. A large component of the security work is to just ensure the threat surface is not compromised and that the business can run. And if that looks like you running these 3 steps and then re-imaging the workstation back to a trusted state, you got the job. I hope that's clear. So don't rabbit hole. Don't get too ahead of yourselves. Make sure you can perform the work that is needed that businesses will pay you for. Otherwise, you're just a very good hobbyist without a job. Does that make sense? Yeah. Doug saying reverse engineering goes deeper, but is different. Yeah, reverse engineering is not retrace steps stack, but deeper does solely. Yeah. Yeah, exactly. Like, so what Doug is saying. So, like, what we've done is SOC Analyst work. Now, there was some level of forensics, right? Like, back on the workstation. Like, here you go. We did defer. It was part of the investigation. I have IOCs and I have threat actor patterns here. I did threat hunting. This is threat hunting. Don't get confused, please, that like you need to be a threat hunting analyst as your job to say that you are doing threat hunting. That doesn't make sense. We just did threat hunting 3 times back to back. Cool. So that's a wrap, everyone. At this point in time, so you have all now been shown and instructed and with some practice now, I think you are now able. J Money, yeah, right, looking too deep. Yeah, you're way too deep. Way too deep. You are now all able to perform that like tier 1 level of Windows Triage using these tools. All what you need to do now is just get more experience, more exposure, go through the labs that we prepared for you, go through the stream that we've done today, go through the challenges. When you're done with that, get ready to go find more malware like that and just keep on getting better with your skill set at that point. More exposure, more experience, different threat operations, different process activity, different DLL activity. Just expand your scope, but the concept is the same. Persistence, process, and networking. Will Low Effect be bringing out supplemental labs purely just within the courses? Well, there's a supplement to this. So once you complete SOC100, you do CDA. Once you're done with CDA, you do our DFIR course, or our detection engineering course. We got plenty of work for you, Jordan. Don't worry. We'll keep you busy. Plenty of roadmap for you to work with. And then on top of that, we're going to continue doing these streams. So after SOC100's wrapped up, like, we'll do more streams like this that are just like dedicated to things. Kind of like what I was doing back in the summer. If you go back to like our YouTube, go to our channel. Not that one. Let's go to level effect. Go here and go to videos. So we have Doug's stream as an example of like supplemental material where Doug walked through the dark web and did some threat hunting. APT case study. And then there's the Facking Friday videos that I was doing in the summer that we're going to get back to. But you can go take a look at like a full DLL injection attack that I walked through and a full Z-loader malware traffic analysis that I walked through as well too. So there's more supplemental material that you can go and work with. And we're going to keep on bringing it because it's fun. Cool. Chaos D2, will you ever show a lab where you're hunting live harmful malware? Yeah, of course. Yeah. I mean, the Z-loader one was malicious. That was live. It's just it didn't do a lot. The RickRoll one, that was actual malware too. Like these are actual malware samples. Will the Cook by Resume streams come back? Yes, they are. As soon as we were done with SOC100, like this was our big initiative to get like the foundation down so that if you're ever stuck with something and you're not sure, you can go back to a SOC100 stream or through the course and get your foundation in check and then be able to make benefit of these things we're going to be bringing back. Resume streams as well. I love roasting a good resume. So that's coming back too. Cool. Well, thank you everyone. This is the end of the Windows Triage module. You now understand at this point, you now understand what a process is, what a thread is, what a DLL is, the PE format, the registry. You understand the Windows internals enough, both from user space, kernel space, and the middle layer in between where the API calls happen, where we can now observe and interact with malware that's been executed for triage. You know how to look for persistence, you know how to look for process, you know how to look for networking, and you know how to use the sysinternals tools that allow you to do that at a much more automated and more sophisticated manner. You now have a SOC Analyst Tier 1 compromise host triage skill set in front of you. Next, we're going to go and take a look at the email side, which will use the same concepts. We're going to look for process, persistence, networking. We're going to look for all three with the emails that we find and look at email types of vectors. And then we're going to look at ELK and a SIEM, which is just Google for your endpoint. That's it. So we're going to be looking for the same things, process, persistence, networking, inside of a dashboard that has a nice aggregated view of logs and events, but we're looking for the same things, just a log and event tool that makes that easier and speeds it up for us. So it all layers on from itself at this point on. You have the skill set, just keep on going. Cool? Sounds good? All right. Awesome. Thank you again for being here today, and have a good rest of your Sunday and your week. Look out for the uploaded YouTube streams, and we're going to be back with them this week. So you can catch up on this stream on the Monday and Tuesday as well. All right. Have yourself a good Sunday, good week. We'll see you back next Saturday. Have a good one, everyone.